let's go ahead and create our torso rig for our character JJ. Alright, so let's go ahead and create the torso for JJ. Woo! Now he's a pretty simple character. He comes with the DVD, but he's going to suit our purposes for illustrating suit our purposes for illustrating what we need to do to create an animator-friendly rig for this guy. Alright, it's good to finally get onto the actual character instead of all this toolkit stuff. Sweet! So the first thing we want to do is make sure that we've got a good working directory to work with for creating JJ. So if we go ahead and take a look in your animator-friendly rigging area, you'll notice that, remember how you set up a library for your objects. You've got a work in progress, a projects directory, etc. Let's go into our library here and into our characters, and we're going to create a new folder. Boink, like that, and we'll call it JJ, because that's the name of the character. You can name it whatever you want, but I like to call him JJ. And then what we want to do is copy JJ from the example files that comes with the rigging DVD. You'll see he's right in there. So we're just going to copy him. And let's go back over to our library. Characters, JJ. Create a new folder. Call it model. And we'll just paste JJ in there. Very exciting. Yay! Okay, now let's go ahead and go to Maya, and we're going to open up JJ to work with. Don't save. And so while this is loading, what we're going to do is we're going to look at how to break apart JJ into what's called a low resolution model. What this means is that if you use regular skinning inside Maya with your animation rig, it's going to be really slow. Like if you start dragging the points around with skeletons and stuff like that, it'll move slowly and your animators are going to get frustrated because things will be going so slow. So if we break it up into little individual pieces of just rigid geometry, it'll be a lot faster. And the reason we want that is because faster is better. So imagine a huge t-shirt and a sign that says faster equals yes. That's what you want. Everything you do should be aiming for getting the right control and also making it as fast as possible. Because the faster the animation rig is, the better the animator is going to be able to try things and animate, and the more choices they'll have, and basically the happier they will be. And that's what you want. You want happy animators. You want very, very happy animators. So what we want to do is just right now we're gonna basically break JJ up into the segments that we're going to be working with on our individual parts. So we're going to have a head, neck, torso, arms, legs, etc. And so it's going to be really rough segmenting at this point, and we'll get into more detail a little bit later. Okay? So what we want to do is go ahead and select JJ, and then we're going to go into component mode by hitting F8 and pick some faces because we want to break them apart. So our goal is to pick everything except the neck, head, arms, and legs. Basically we want to grab just the torso of stuff. So if we go to this lasso tool here and we start picking things, we're going to grab a whole bunch of stuff. Like that. I want to make sure we grab his legs correctly. Hold down Shift. Let's go into a perspective view and see what we've got. I want to make sure that we grab those bits there. And if you have trouble seeing what you're actually selecting, you can go ahead and change the colors. If you go to the settings and preferences, color settings, go under active, components, and then scroll down until you see the polygon faces, and just change the color to something that is a little bit easier to see against the color of JJ. we'll make sure we grab those guys. Like that. Get these two. And you just really want to make sure that you've got him. Like all those little facets selected. Don't forget his belly button there. And that's everything. Cool. So once we've got everything, what we want to do is separate the polygons. So if we go into polygon mode and we go to edit mesh, make sure keep faces together is on. If you have them individual, if you have that turned off, whenever you separate, it's going to be individual little polys, which you definitely don't want. Then we go to mesh, extract, and mesh separate, just in case. And then go edit, delete by type, history. And now you'll notice that we've got the torso as an individual object. We've got that arm, that leg, the head, that arm, and that leg. And there we go. We have separate parts for him. Yay! But what we want to do is actually name these, because otherwise it's going to be very confusing. We're not going to know what things are. So let's go ahead and go to polysurface 1, and we'll call this torso geo. The next thing here is our arm geo, our leg geo, head geo, L arm geo, and L leg geo. Cool. Now we want to save this as something that we're going to be working on later. So we're going to save this into the low res geometry directory. So if we go back here, you can see we've got model. Let's create another new directory. We'll call this model low res. And you can use whatever naming schemes you want for your model structure, directory structure. I'm just naming them like that because I like it. We'll go back up, model low res, and we'll just call this JJ low res, like so. Okay. So remember I said that we were going to work on the torso area, and what we want to do is make it so that we can basically bend this guy around and do exactly what we were doing with our little test earlier, where we have a spline IK going from the hips to the shoulders, and as you move the shoulders, the back bends and it deforms very nicely. So in order to do that, right now obviously this is just one piece of geometry which can't really deform and we can't bend it. So we need to segment this up into little sections, just going across like that. So how do you determine what those sections are and how you're going to break them apart? Well, first of all, you need to figure out how many sections you're going to use, and then second of all, you need to break them. So if we have two sections, that means that basically we can bend right in the middle, and that's about it, which isn't really going to be enough to get the kind of deformation that we want. So you know you need more than 2 segments. You also don't want to have like 37, because every extra one you have is going to slow things down a bit. If you have a whole bunch of breaks in here, it's just going to be too much information for the animator to deal with. You want to kind of come up with a good number that is sort of in the middle and gives you the amount of deformation that you need, but will be fast enough. So I usually work with, for torso, 5 or 6 segments, depending on the character. I think on this one we end up working with, say, 6. So what we want to do is now segment the body in those little sections. So what we're going to do is first we need to get an idea of what the shoulder area is and what the hips areas are, because those are going to be individual pieces that we don't worry about. Those aren't going to be deforming too much. They're going to be moved around by our controls, and then the little bits in the middle are going to be followed by the guts. They're going to be moving around with the spline IK. So the first thing we need to do is segment out the shoulder and hip areas. To do that, we can either select little facets like we were doing before, or we can use this tool called the cut plane, which is basically a script that you get that makes it a lot easier for cutting areas, or cutting up pieces of geometry. You can do that by selecting the geometry and then click on Add Plane for cutting polygonal geometry. Pow! Which will create a plane that just sort of sits in the scene. And then you can sit here and rotate it and get it to be in the right position and the right angle for you to cut right through that geometry. So if we go to a side view, what we want to do is get a nice area for the hips and the bum that we're going to be using to work with here for JJ's geometry. So I'll choose a bit apart, like right around here for the hips, and then we'll make another one just by clicking on that plane again. Make sure that it did it. It does. And we're going to drag up to get a point, say right around here, which is going to be for the shoulders. Just like that. And by using these, we can visually see where the character is going to be cut and get a good idea for the type of controls that we're going to need and the type of deformation and everything. So I'll just cut right there below the armpits. And then in order to actually do the cutting, we use this button on the shelf, the Cut Selected Objects with Plane. So you go pshonk like that, and it automatically breaks the object into the pieces that you specified here. Now unfortunately, or fortunately actually, we get this piece, and that piece, which is great. That's exactly what we want. But they're kind of named funny. So they're all called Torso Segment 1, Torso Segment 2, Torso Segment 3. So let's rename them. This one is going to be Hip Geo. This will be Body Geo. And this is Shoulder Geo. So let's hide all the geometry except for the torso, so we don't have to look at all this stuff. It'll make it a lot easier for us to work with. Hide. Like that. So we've just got the torso here now. Okay? Now, we want to break apart the mid part here for our skeleton, or for our rig. The best way to do that is, because I don't actually know where to break apart, we want to break apart the joints, and I don't know where those joints are going to be. So, the first thing we need to do is create the skeleton for this. So, what I want to do is we're going to go from the base of Body Geo to the top of Body Geo, right there. We just want the guts to go in between the shoulders and hips, much like how we did with the boxes. So, to do that, first I'm going to hide the hips and shoulders temporarily, just so I don't have to see them, because they can get distracting. And then I'm going to create a joint segment going from the base, right here, up to the top. And you want to kind of go directly up the middle, because I know in the real world, in real world land, backs kind of go like this. They have like a bit of an arch to them, or an arc, like that, which is great, but what that does is that means that our rotations for things like the spine and stuff are going to be aiming along this angle, which makes it a lot harder to spin the character around in 3D and 360 degrees and stuff. So what we want to do is make things look right for the animators and work right for the animators, and then they'll make sure the character stays on model and does the right thing. So first thing we'll do is we'll click down here at the bottom, and then we'll hold down Shift, which will constrain vertically, and we'll go up to the top and click like that. And now we've got joint 1. Ta-da! Woohoo! But we want to split this joint up, because right now it's just one big thing. So we're going to go here to the Split Selected Joint, click on that, we'll choose 6 segments, click OK, and then that's going to create 6 segments there for us to work with. Cool! Now, we want to create cutting planes to break apart this geometry. So this first joint is the first place we're going to create a cutting plane, because we already have the bottom of the geometry there. We just need to cut right across here. Okay? So we will create that, and then we're going to move it right to here, rotate it 90 degrees, so it's like that, and we'll have it lined up exactly right. So it should intersect the torso. It doesn't have to completely intersect the torso, like it can work if the plane is like this, because what it's going to do is just look out past infinity, all the way past infinity. If you can go past infinity, it'll look out that far to figure out how to cut the torso. So we'll add another one, and we'll just basically keep moving these up. Add another one, like that, and another one, and another one. So we'll end up with cut planes that look just like that. Okay? Woohoo! Look at all those cut planes. Very exciting. Then we can select the body geo and just cut, and it'll automatically break it apart like so. Okay? So now we want to go ahead and name things. But notice how many pieces of geometry there are. There's 7. And notice how many cut planes we had. We had 5, and there's 6 joints. So somehow we've got an extra cut plane. And what happens is, up at the top, these 2 pieces here weren't actually physically connected. So it created 2 separate cut planes. So we need to merge those, because otherwise you're going to have those 2 pieces of geometry. So we're just going to go to polygons, and we'll go to mesh and combine. And then edit, delete by type, history, like so. Okay, now we're going to rename all the geometry so it makes more sense. So this piece of geometry here is down there. We're going to call this torso 6 geo, because that's what it's going to go on. This is going to be torso 1 geo, torso 2 geo, torso 3 geo, torso 4 geo, torso 5 geo. There we go. And then just to keep things easy, we're going to put all these pieces underneath torso geo. We don't need the body geo anymore. We'll delete that. And can't forget about that piece. Like that. So now we've got hip geo, shoulder geo, which are both hidden, so we'll show them. And then we've got torso 1, torso 2, torso 3, torso 4, torso 5, torso 6, which are totally out of order. Haha. So we want to make sure that they're named correctly in order. So that's torso 1. Let's rename all these temporarily to Bob_hash_geo. This is a great tool for when you got to do stuff like this. And then this one, this one, this one, this one, that one, that one. Torso hash geo. There we go. So that's 1, 2, 3, 4, 5, 6. Just like so. And then what we want to do is save the latest version of this so you can get back to it at a later date. And now we're just going to unparent torso geo here, so we have to work with that only. And we're going to collapse JJ group, make sure that's hidden, and then we're not going to worry about it for now, because all we want to do is really work on the torso. So we're just going to keep the rest of the stuff hidden, and we'll keep on moving. So first thing we need to do is rename the joints. So right now these are joint 1 and all sorts of crazy things. So we'll rename these using our rename tool, torso_hash_joint, like so. And then we're going to apparent the geometry to the appropriate joint. Okay? So from under here, we're going to take torso 1, parent it to torso 1, parent torso 2 to torso 2. You can either do it in the outliner, or you can go in the 3D view, hit parent that way. Parent, parent, oops, parent, like that. So we've got each of these torsos joints parented correctly. Cool, with the right geometry. But notice that the hips and shoulders aren't parented to anything yet. That's because we don't have joints for them yet. So we're not including them on the Spline IK system. We want their motion to be completely driven by the hips and shoulders animation controls. So we need to create joints for each of them. So to do that, we're going to select torso 1, and I like to do this a lot where I'll duplicate something and then rename it and delete the children, just because I know that that means the object is going to be the same as the one I'm duplicating. So I'm going to duplicate torso 1. I'm going to delete all of its children because I know that now it's going to be exactly the same as torso 1, and I'm going to call it hip joint. So now I've got a hip joint that's exactly the same as the torso 1 joint. Okay? And then I'm going to duplicate that, and we're going to call it shoulder joint. And we're going to move it, and I want it to be in the exact same position as this one. So I'm going to hold down V for point snap, and then I'm going to click with the middle mouse button right around that joint, and it'll snap it there. And now I've got the hip joint, and I've got my shoulder joint. So we need to put the hip geo underneath the hip joint, parent that, shoulder geo underneath the shoulder joint, parent that. Let's delete this torso geo. I like to delete nodes that I don't need as I'm creating and as I'm working because it cleans things up and keeps things tidy and orderly. Okay, so we've got our torso here. We've got our joints that go up the torso, which we can use to manipulate the back. We've also got the hip joint, which we can grab and move around. And we've got the shoulder joint, which we can grab and move around. But we need to make sure that we've got some animation controls that we can use that make sense to the animator. So what we're going to do is take a look at a couple of examples. Now, how do you determine what the right controls are? Well, I like to create, just like we did with the bouncing ball, I like to create animation or NURBS curves that I can use to drive the geometry, just because they're easy to hide, easy for the animator to tell what they're used for, because you've got these curves sitting in the scene. They know they can pick them and grab them, and that's about it. And you can design them to make sure they look like something interesting. So here are a couple of tests or a couple of examples of things that we could possibly use. There's some cubes, looks like little boxes. We got circles here. We've got more circles oriented differently. In this case, the hip is flat and the torso is vertical. And then here's one that's a little bit crazy. You can pretty much do whatever it is that you want, but I kind of prefer a more minimalist approach than something like this one over here on the right, and something that really helps define what it is that the control is going to be doing. So if you look at what each of these things need to do, for example, we've got a control that needs to be able to translate and rotate the shoulders and also the hips, translation and rotation. So if you have something that's translating, something I like to do is use arrows, because the animator can look at it and go, oh, arrows, that means move, I understand that. And if you're rotating, something with curves makes sense because, well, the rotation manipulator has curves. So we can create a NURBS curve type of icon control that represents these two things. If we take a look at our import directory for the example files, just go to File, Import, and inside the example files area there's something called icons. Let's go ahead and grab circle arrow, and you can see what this looks like here. Basically some arrows and a little bit of curve on there, which kind of represents to the animator, hey, maybe this thing can rotate and it can also translate. There's another one as well that we can use, and this one's going to be called circle arrow 2. And that's right here, circle arrow 2. Click import, and that's right there. See? So now we've got our two different controls that we can use, one for the torso and one for the hips. Let's go ahead and position them correctly. First, let's rename them. This bottom one here is going to be called hip anim, because it's going to be used for animating the hip, and this one will be shoulder anim. Notice I'm using the _anim suffix here because this allows us to do things like select quote star _anim if we want to select all the animation controls, etc. So let's move this over to where the hip joint is. So I'm going to select the control, and then I'm going to hold down the V key for point snap and middle mouse button drag around the joint, and it'll snap right there. And then we'll do the same thing for the shoulder control. Select that, V, middle mouse button, release. But it looks a little bit funny, so let's just rotate it 90 degrees in Z, and then I'm just going to scale it down a little bit so it fits around the body a little bit nicer. And there we've got our two controls positioned exactly where we want them. Now if we look at our actual animation values on the controls, for example on shoulder anim, you can see we've got translate X, Y, and Z as 0, 2.41441 and negative 0.246. The rotations are 0, 0, and 90, and then the scales are crazy. These values are fine for positioning, but once the animator starts working, it's a good idea to allow them to zero out controls like this to make sure it's easy for them to get to a default torso position. So I'm going to select both of these controls and then go to Modify, Freeze Transformations, and go to the option box. And this will allow me to tell the controls here to basically set everything to 0. So translation, rotation, and scale. Freeze those transforms. And now you can see that if the animator wants to zero out the shoulder or the hip, they can just type in 0 for the translation and rotation, and they'll automatically go back to the default. It's good to think about how the animator is going to interact with things like this and what a good default value for 0 is for pretty much every control you're working with. Now it's time to constrain the controls. Notice that as I move the shoulder anim control around, nothing's really happening. That's because the shoulder joint isn't moving with it. So I'm just going to select the shoulder anim and then select the shoulder joint, go back to animation mode, and choose Constrain Parent. And that will mean that when I then grab shoulder anim and move it and rotate it, those rotation values and the translation values will transfer through to the shoulder joint. And then we'll do the same thing for the hip. Constrain Parent. Now the hip will move along with that. Before we continue on to actually hooking up the back, we should check out the rotation orders. Remember that we always want to make sure our rotation orders are correct for our animation controls to make them easy to animate. So we want to change the rotation orders for the hip anim and the shoulder anim so that if we were to take both of these controls and rotate them 90 degrees in Y, we would still have rotations available in X and Z. Right now, the default rotation order says that if we rotate 90 degrees in Y, we lose our rotations in one of these axes. So notice how X and Z are almost lined up on top of each other. We need to change our rotation orders to allow for that. So if we look at the hip anim, you can see the rotation order is X, Y, Z, which means that if we move Z, both X and Y move. If we move Y, only X moves, and X will be the last thing evaluated. So we're going to change that to make it so that Y moves everything. And here what I like to do is choose ZXY. So we'll change that one. So now, if I rotate like this, notice it moves both the X and Z. So I can move 90 degrees and I can still go side to side and up and down. But we want to do that for the hip anim, for the shoulder anim. We want to make sure those are both the same. And since the hip joint and shoulder joint are constrained to hip anim and shoulder anim, we want to make sure that we change the rotation orders for those two guys as well. Because if you have the rotation order for your control object one thing and the rotation order for the thing it's controlling something else, it may not transfer the rotations correctly. So we'll just select all 4 of these things. And then if you click over here in your shelf, the change rotation order on selected objects, you'll get a little window that pops up. This is just a script to make it really quick to change the rotation order on multiple objects. We'll choose ZXY and set rotation orders. And notice now that the rotation orders for the hips is ZXY, the shoulder anim is ZXY, and same thing with the hip joint and the shoulder joint. All that is set up for you automatically. And we'll continue on with setting our animation controls to make them how we want our animators to work. What we're going to do is come over here to the channel box, and we don't want the scale or visibility to be available for either the hip anim or shoulder anim because we don't want the animator to accidentally pick them. So I'll just select them in the channel box, right mouse button, and choose lock and hide selected. So for our hips and shoulders, we've got just translation and rotation available, and that's it. And they're both set to 0, so it's really easy for the animator to work with. Now that we have the hips and shoulder animation controls ready to use, it's time to set up the spline IK on the back, because right now the back's not moving with it, which is bad. The animator would be like, dude, WTF? That's not moving correctly. So the good thing is we've already figured out how to create the back because we tested it beforehand. That's why it's important to do these tests so we can follow the exact methodologies that we came up with before, and we can rig a lot quicker. So let's go ahead and create the spline IK control on our joints. Okay, So we'll go to Skeleton, the IK Spline Handle tool. Go to the option box. Make sure that it's everything we want, which it is, everything that we want it to be. We're going to click on Torso 1 joint, and then we will go down and click on Torso 7. Pew! That one. And now we've got Spline IK that travels through the entire thing. Remember, if I select the curve, I can go into component mode, pick these points, move them around, and our back moves. Very exciting. Let's go ahead and rename all the parts so that they're named in a way that makes sense for us. We'll double click on the IK handle 1 and change it to back_IK handle, so we know that's for the back. Select the curve 1, change that to back_curve. And then over here, the effector, which is the end of the IK control chain that tells the IK handle how far down to go, we will change the name of that to back effector, and we'll spell it correctly with 2 F's. Or you can call it the back effectatorama. Now we want to attach the curve, the back curve, to the hips and shoulder controls. So what we'll do is we'll just select hip joint, select shoulder joint, select the back curve, and then we're going to go to skin, bind skin, smooth bind. Just like that. So now if we take hip anim and move it, woo, you can see that it's actually grabbing the back control and moving it around. We can grab the shoulder anim, move that, rotate it, and our back is moving with it. Very cool, except remember, it's not stretching and doing what we want. So we need to come up with a way to tell it to stretch and squash and stretch. So we could set up things the way we did before with the curve info node and measuring the length of everything and stuff like that, but that can take a long time. So we have a script here to make this a little bit easy for you. The script comes with the DVD, and it's called js_create stretch spline.mel, which will automatically create a stretchy spline with the control curve for managing the volume preservation. So if we go ahead and select the back curve right there, and then we click on this button here in the shelf to create stretchy spline, like so, you'll see that we have something called back curve, and we can tell it to maintain the volume by turning that on. And we'll talk about the world scale a little bit later. I'll just close that for now. Click apply. Now if we take our control and we move it up and down, you can see the back stretches and we get some volume deformation. So if we go ahead and we take the back control, we move it up to say a value of 2, so we can see it all the way up there, and you select back curve. If you bring up your graph editor right here, the little scale power attribute, that's the thing that we're using to control what the back does. So I'm going to just go ahead and create a key right in the middle here, and if I just move this thing around, you can see how it affects what our spine is doing. So you can go ahead and modify this however you like to get the exact type of deformation that you want. You can move it over. You can even do things like create 2 curves, 2 keys on there, so it kind of scales up and then scales down and scales up if you want. But that looks a bit silly, so we won't do that. We'll just go ahead and set it to look something like that. And now when we take this, we go down and up and down and up, we get some really nice volume type deformation right in there. And again, because we can set these to 0 to get our default position, we get exactly what we want. And notice the rotation works really nicely. We can move the hips around, woo, woo, woo. And it all works just how we want. Let's go ahead and go back to our outliner here. The next thing we need to do is add the twist controls, because notice as I'm twisting, it's not rotating correctly. So to do that, we're going to select the back IK handle, bring this a little bit smaller, and we'll go to the attribute editor. And then we want to take a look at the advanced twist controls. So we go over to that. We're going to enable the twist controls. And remember, we set the world up type to object rotation up, start, and end, because we're going to look at the object rotation for the shoulder and for the hips. And that's why we need object rotation start and end. And then we're going to go to the up axis, which we want again to be negative z, because we're looking along the z-axis here, and we want the back to point away from that. So that's negative z. Our up vectors are going to be 0, 0, negative 1, 0, 0, negative 1. And remember, up vector is basically what direction it's pointing. And then we have to tell it what the world objects are going to be. So the first one is the hip anim, because that's the start of the IK spine, and it goes up that way. World up object 2 is going to be shoulder anim, like that. So now if we pick this guy and twist it, the back will twist correctly. Grab this one, twist it. The back twists correctly. We can stretch and squash it. And notice that as we move around, we get a very predictable exact behavior of what we want. So it looks like we have our two controls for our IK, for our shoulder and for our hips, following all of the rules that we have set up of our rig requirements. But let's double check just to make sure. It's always good to go through the checklist. Okay, so for our IK controls, we have simple controls. Yes, they're very simple. It's just hips and shoulders, two controls, move exactly how we want. The animation should be easily transferable, meaning that we can copy the animation easily from the hips and shoulders to another object with hips and shoulders. We don't have to worry about it affecting the rig itself in terms of like how the joints work. It's just the animation controls. The controls should be unique and understandable. They are. It's hips and shoulders. Hips, you know, if you grab the hips, it moves the hips. Shoulders, if you grab the shoulders, it moves the shoulders. The icons make sense. It all is easy to follow. They have the correct rotation orders. We went through and changed those, so they are correct indeed. They're named correctly, hips and shoulders. And the limited key ability. That's exactly right. We can only set keyframes on the things that we want. So just keyframes on that, and just the keyframes on that. Cool. Now the next step is to go ahead and add the FK controls to our rig. Right, so we're going to be adding the FK controls, but how many controls do you actually need? If you're going to be creating a joint structure, what do you want to do? Do you want to add 1 joint, 2 joints, 3 joints, 47 joints? What is it? Well, I like to do the minimum number of joints, because every joint you add is another one the animator has to touch and control. So I like to do the minimum number of joints necessary to allow you to get really nice fluid motion. Notice on the bottom here we have 1 joint. If you go from right to left and you sort of rotate, or you go from left over to right, you can see that it's not very easy to get good fluid motion. And the second one here, if you go from left over to right, you notice that as it starts to rotate down, you can get a little bit more fluid motion. You can kind of break the joint here and allow it to overlap, but it still doesn't look quite right. With the top one with 3 joints, you can get some really nice fluid motion, and 3 joints is still pretty minimal. It's not too difficult to control for the animator. So that's usually the joint number that I like to choose, but it's up to you. If you want 47 joints, you're more than welcome to be able to do it, unless I am animating for you, in which case I will tell you, no, go back and make it 3. And if you say, no, we're going to have 47, I will say, no, you will not, and we'll have a brawl. It'll be awesome. It'll be a very fun brawl, with lots of slapping and stuff like that. Anyway, so let's go ahead and create the joints. So we're going to go into wireframe so we can see what we're doing. And I'm just going to go to skeleton joint tool. And while holding down V for point snap, I'm going to click boink right there at the bottom of the joint. And then I'm going to click boop right there. And so we've got 1 joint structure going from the bottom all the way up to the top. Okay, now before we get going and segment the joint, it's important to make sure the orientation of the joint is correct. This isn't the rotation order, you know, X, Y, Z, Z, X, Y, etc. This is the joint orient. It's the thing that controls the direction the object rotates when you change a rotation value. For example, if we were to take 2 joints, I'm going to create one, go to there, and then another one here to here. Then I'm going to display the rotation orders for each of these joints, or the rotate axes, sorry. Right now the rotation axes are exactly the same. Z points to the left, Z points to the left. However, if we were to change that rotation order by going to orient joint, telling it to be second axis orientation of positive X, you can see that Z points this direction on one object and this direction on the other. If I select both of those and I rotate them in Y, notice what happens. The same value will point the joints in opposite directions. What this means is that the animator is going to look at their graph editor and they won't know intuitively which direction something is going to point when they rotate it. Let's take a look in the perspective view. So see how the joints look the same, but their axes are pointing completely differently. So the joints can look exactly the same but behave totally different depending on their orientation. So understanding this orientation is important because it helps the animator tweak their animation. Make sure that they can get the type of motion they predict. So what we want to do is make sure that this joint that travels up the spine here, which is actually in the wrong position, we'll just make sure it's snapped correctly. There we go. We want to make sure that if they put a positive value in X, for example, or in Z, so it rotates down that way, that it's going to behave exactly the same as this joint here. So let's take a look at, let's get rid of these two guys, we don't need them anymore. We'll take a look at this joint, and we're going to turn on its local rotation axis under Display, Transform Display, Local Rotation Axis, and you can see that Z is pointing that way, X is pointing up, and Y is pointing back behind. Let's also take a look at the shoulder animation control and see what its rotation axis is. Here we've got Z pointing in front of us, or towards positive Z, X pointing out to the right, and Y pointing up. So you can see that the rotation axes, the orientation, is not the same on these two joints. So we need to change the rotation order on joint 1 to make sure it's moving correctly. Let's go ahead and do that. So if we go to Skeleton, Orient Joint, bring up the option box, you'll see that there are a bunch of options here to change the way the joint is oriented. So what does all this stuff mean? Because right now it's kind of confusing. You've got orientation of XYZ, YZX, ZXY, ZYX, etc., 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 and a second world axis orientation, and then these other things. It's a little bit confusing. So here's how it works. First, we'll take a look at the first orientation, this orientation setting here. The first axis, which is X if we have XYZ picked, or Y if you have ZXY, but in this case we have XYZ picked. So the first axis will be the axis that aims down along the joint. So notice how XYZ here, X is aiming down along the joint that way. Just like that. The second axis, which is this one, or sorry, Y, the second axis here, is the axis that's going to orient with the world axis that's specified in the second world axis. So right now, Y is being told to follow with positive X going down here. So let's see what would happen if we told it to go ahead and apply that. Notice how X aims up and then Y follows the X axis. Let's see what would happen if we change that to positive Z. So X goes up and Y follows the positive Z axis, just like that. But what we want is we actually want the Y to aim up along the joint and then X to follow along positive X. So is there one here that we can use where Y follows along the joint? Well, we've got this one with YXZ, and then we want the X axis to follow along that way. So if we try that, we now get Y going up, X oriented to follow the world axis, and Z pointed whatever's left. So does that make sense? We've got the first axis here again is the first axis specified there is the one that follows along the joint. The second one is the one that's going to follow along the direction you tell it with the world axis here. And so that's why YXZ will point Y up along the joint, X along whatever axis we specify. We specify positive X, so it'll do X along that way. If we chose negative X, it would put X negative that way. But we want positive X. Apply. And there, now we've got this joint oriented to follow exactly what the shoulder does and what the hips do. So if we select both of those, and we rotate in positive X, they move exactly the same. Same thing with Z, and same thing with Y. Just like how we want. Alright, so the next step is to change the rotation order, but first let's turn off the display of the local axes because that can get distracting. So we'll go Display, Transform Display, Local Rotation Axis. And then we'll change the rotation order for joint 1 to match that of the shoulders and hips. And if we look at the shoulders and hips here, you can see the rotation order is ZXY, so we want the same thing, ZXY, for that guy. It's always important to make sure these things all stay the same. Now we're going to create the rest of the FK joints for the back. So we'll select joint 1, and then we're going to choose the split selected joint tool, boink, like that, and we're going to change the segments to 3, because we only need 3. And there we go. We got 3 joints going all the way down like that. And we need to rename them because right now they're a little bit confusing. So we're going to name this first one torso base joint. We'll name this one joint torso 1 anim, and this torso 2 anim, and this torso end joint. So why did we name torso base joint something different? Why didn't we name this torso 1 anim, that torso 2 anim, that torso 3 anim, and that torso 4 anim? Well, right now we've got, this is the base joint that we're going to be using to control the entire back, but it's kind of hard for the animator to really see what it is they're going to be working with. And what I want to do is actually create a control on top of the entire back that's going to represent the motion for the whole thing. And I don't want to use this joint to do it. I want something else to do it, and then have this joint follow along with it. So we're not going to actually allow the animator to use this joint. This will make sense when we go a little bit further. But for now, all we really want them to animate with is torso 1 and torso 2. And torso end joint itself doesn't allow for animation either. Okay? So just like we created controls for the hips and shoulders, we need to create a main body control that we're going to use to control the entire rig. So we want something very simple looking, something that's not going to distract the animator, but something that gives an idea as to what the control does. So one thing that we could do is create a square around the whole thing. We could create a sphere that surrounds the whole thing. We could create another crazy curve in order to do it. But I think a square gives us a good, simple type of control that's easy to understand and isn't too distracting, because we don't want to flood the animator with too many options. So if we go to File, Import, there's something here called Square Curve. So we'll pick that, and you can see there's our little square curve that we can use. And we're just going to go ahead and position it to the same point as the body. So we're going to choose our Move tool, hold down V for point snap, and then put that right on that joint. And there we go. So you can see that it's pretty clean, easy to look at, not super distracting, but if we select it, we can then use it to manipulate the entire body. So first we need to rename it. So instead of square anim, it's going to be called body anim. And then we're going to freeze the transformations. So we choose modify, freeze transformations. So it's only got our 0, 0, 0. So we can't get distracted by, or the animator doesn't have to choose crazy numbers to reset it back to its default position, which is good. And then we're going to parent the torso base joint to body anim. So we'll do that. Torso base joint is now a child of body anim, so we grab that and move it. The torso is going to follow. And then we want to parent the hip anim control to the torso base joint so that it follows along. Now watch what happens if we just go ahead and parent it. Notice how hip anim suddenly gets values in it. And the reason for this is because if you just parent it directly, in order for Maya to make sure that this stays in the same place, it stuffs some values into the translations in order to maintain the offset. But we don't want it to do that. So what we're going to do first is just sort of group hip anim to itself, and we'll call this hip group. And then we'll parent hip group to the torso base joint. So it's going to stuff those values into hip group, but leave hip anim alone. And then we'll do the same thing for the shoulder. So we're going to group shoulder to itself, and we'll call this shoulder group, and then parent shoulder group to torso end joint, like that. So now shoulder anim leaves its values at 0, hip anim leaves its values at 0, body anim, move the whole thing around, Then we can take torso 1 anim and torso 2 and we can bend them and we can twist them and they move around the hip anim and the shoulder anim, or we can grab the hips and shoulders and move them independently. So what we've done is we've just parented the shoulder anim to the end of the torso FK control, the hip anim to the beginning of the torso FK control, and then the torso FK control itself to the body anim. And that way body will move everything around. And if we move the FK controls, it'll move the IK controls automatically, and then the IK controls can be used as an offset to the FK. Now we just need to change the rotation order of body anim, and again we want to use the exact same rotation order that we used for everything else, so it's consistent for the animators. That's Z, X, Y. So now we can rotate 90 degrees in this direction. We can still go side to side and up and down, or forward and back. And finally we want to add the pivot control for the animator. So let's go ahead and select body anim, and then we'll go over to our pivot create button on the animator friendly rigging shelf, add that, which creates the animation body pivot for us, and then we're just going to hide it for now because we know it already works. So remember, if we actually have it visible and then we go ahead and pick the move pivot and move it over here and then click snap, when we move body anim and rotate it, it rotates around that pivot. So it does work, just as we know it would because we set it up correctly. Yoo-hoo! So let's go ahead and hide that for now, and we've got the pivot set up correctly. So we need to next make sure that our animation controls are set up for making sure that the correct things are visible and not visible. Okay? So if we go ahead and select body anim, we want to make sure that we only have translate X, Y, and Z and rotate X, Y, and Z available for animation. So we'll go ahead and hide and lock the scale and visibility. Let's look at the back controls. So we've got torso 1 anim and torso 2 anim. Now we only want the animators to be able to rotate these guys. So let's go ahead and take the translation, scale, and visibility, and we'll choose lock and hide selected. And then for the radius, we'll just select that and choose hide selected because it's already locked, so we can't grab that. For the base joint and the end joint, we don't want the animator to be able to do anything. So we'll select all those and lock and hide selected. If you don't do that, the animator can then translate these guys around. So now we know that they can't do anything there. And same thing for the shoulders group and the hip group. We don't want the animators to be able to do anything. So we're going to select those and lock and hide them so they can't actually grab and move those guys. Okay? So the only things they can animate are the body anim, the hips and shoulders, and then the torso 1 and torso 2. And those can only be animated with rotation. So let's take a look at our FK controls and see if they make sense for what they fit the requirements for what we want. Simple controls, yep, you can just grab it and rotate it. The animation is easily transferable, sure enough. Controls should be unique and understandable. Well, it's just rotations, so it's pretty understandable. The controls have the correct rotation orders, they do. The controls are named correctly, they are. And there's limited key ability. Indeed, we've taken care of all of those things. So we've limited the control selection, we set up some display layers, we made sure that only the controls can be selected, and we provided the users with an ability to turn on and off the controls easily. Next is to create a clean rig presentation where we remove any unnecessary objects and expressions, group everything under one node, make sure that everything is named in a way that makes sense, and provide an interface for the rig if it's necessary. The first thing I like to do is make sure that the outliner is clean and it's easy for the animator to tell what's going on. Notice right now if you look at the outliner, we've got JJ group, torso 1 joint, hip joint, shoulder joint, back IK, back curve, body anim. The animator will look at this and kind of just start grabbing things and moving around, doing stuff that we probably don't want them to do. So what I like to do is just sort of group all this together in a way that makes the animator kind of comfortable. They open this up and they can look and not see this crazy messy outliner. So what we're going to do is take body anim first, and we'll just group it to itself, and we're going to call this anim group. And that way we're going to group all of the animation controls into one place. Then we're going to take all of the other controls that we've got, all these guys here, and group them together. And we're going to call them do not touch group. So now we've got two groups. Anim group, which is all the animation controls, and do not touch group, which is all the stuff that we don't want the animator to touch. And in fact, we so don't want them to touch it, we're just going to lock all the attributes here. Lock. So the animator can't pick this and start moving things around. Then we're going to select both of these, group them together, and we're going to call this all_anim. So now we've got an all control, which can move everything around that everything is under. And we've got do not touch group and anim group. Notice I'm leaving JJ group separate because this is just all the extra geometry that we'll be using later. So we'll just keep that hidden for now so that people don't, because we're going to end up, combining everything with the rest of the rig, so we don't need to worry about it. But if we've got all anim, let's see what happens if we actually take all anim and move it around. Notice how the back kind of double transforms. It starts moving a little bit crazy. This means that the reason this is happening is if we look at the do not touch group, you can see there's a back curve over here that we're using to control the back, but we're also moving the body controls and everything else at the same time. So when we move all anim, do not touch group is moving and the body controls are moving, which means that the back curve is getting double transformed, meaning it's moving twice. There's two controls moving it at once. The great thing is that we can solve this by telling the back control itself to not be moved by anything except for the skinning. In order to do that, we'll go to the back curve and see here this checkbox inherits transforms. If that's turned on, that means that the curve is going to be inheriting the translation of its parent. If we turn that off and then grab all anim and move it, the back curve is only being controlled by the skinning, so we don't end up with that double transformation. So that's a big thing we need to do, and that's one of the reasons why you want to test stuff when you start cleaning things up and moving around to make sure that you don't run into situations like that. So we've turned off the inherits transform, and now we can move all anim around, and the back moves correctly. But what about scaling? What happens there? I know a lot of people don't like to scale their characters, but I'll bet you anything that at some point you're going to have your character in a shot and the director will go, can you just make that 10% smaller? And if you don't account for the fact that you might need to scale, you are going to be in a world of hurt, my friend. So, let's see what happens if we scale all anim. Grab that and scale it. Notice how the back is starting to explode. It's like, shoo! The reason for that is because we're measuring the distance of the curve to control how the back is moved, like how the joints are stretched as the back is stretched around. But when we scale all anim, the distance of the curve is growing even though the entire rig is scaling. And because the entire rig is scaling, then those scales are getting multiplied and we end up with more scaling happening than needing. So we need some way of fixing this. Luckily, we can do this by looking at the expression that's created by the back scale and fixing that. So let's go to our animation editors, look at the expression editor, and we'll go to the back curve expression. And so here we've got the scale is curve info 1 normalized scale, which is the normal scale. Square root is 1 over the square root of that. And then each of these is applied with the power attribute there. And so what we want to do is replace this line with something that's going to look at the actual scale that we're having for all anim. So if we do all_anim scale y, like that, and close this, now when we scale, it's saying that as the scale is growing bigger, we're going to divide the length of the curve by whatever the scale of y is, and then based on that, that will be our normalized scale. That's going to be set to 1. So that even though the curve is now 2.248 times bigger than it was before, our scale y is 2.248, so we'll divide by that, and everything will work correctly. So now we can translate this, we can scale it, and our back will still work correctly. But something that's kind of important to realize here is that in order for this to work, we have to scale the character uniformly. So if we scale like this or we scale like that, it may work until we start rotating and translating things off axis. And now notice that because it's scaled funky, it's going to blow up. There's ways to fix this, but I find that in general, the director isn't going to want you to scale things non-uniformly because it's going to put the character off model. They don't want the character to suddenly go like that, and that's just going to cause more headaches than it's worth. So what I like to do is just connect the scale X and scale Z to the scale Y so that scale Y is always driving both of those. So you don't have to worry about the animator scaling things incorrectly. So we'll go to the connection editor, and let's just turn off the display of non-keyable attributes here. And we'll say reload right. We'll say the scale Y attribute here is going to drive the scale X and the scale Z. So now if I drag scale Y up and down, you'll notice scale X and scale Z will move around with it, which is very cool. So we don't actually need to see scale X and scale Z in the channel box now. So I'm going to select both of those, and then we'll just choose hide selected. So now all we see is scale Y. So when the animator saves a keyframe for all anim, they'll just get the scale Y attribute, which is cool. But instead of looking at scale Y, wouldn't it be nice if there was something that actually made a bit more sense to the animator? Because right now you look at this and you go, okay, well I want to scale it. I will use the scale Y because that's just the attribute we're choosing. But instead of using scale Y, I like to name attributes in a way that makes sense for the animator. So we'll bring up our script editor, and there's a really cool command you can use called alias adder. And what that does is allows you to create an alias for an attribute. So we'll choose alias adder, global scale, and then that's going to be the name of the attribute. It's going to be the global scale for the entire character, and we'll set it to all underscore anim scale Y. So if I execute that, you'll notice that now in the channel box, the name of this attribute is global scale, and it's got a value of 1, which means that's its default. I can still use the scale the scale control itself to get that to work, and it'll automatically go through to the expression and work correctly. Now we could have just added another attribute under channel add attribute and called that global scale, but then we wouldn't have been able to use the scale manipulator to do it. And I really like using the scale manipulator for this. So that's what we're doing. Okay, so now our rig is clean. We've got the outliner looks pretty good. We've got all anim. We can grab and move it around. Underneath that, when we open up, we've got do not touch group, which the animator is now told not to touch, and everything's locked out so they can't touch it. Anim group, which is where the animation is, and then under that is all of our animation controls. We can also take the entire rig, move it, scale it, and the rig works underneath it exactly how we want. But if we take a look in wireframe, you can see that the rig isn't quite as tidy and clean as we would like to see. You can see you got all these joints here showing up and down the back. This is a bit distracting. I think it's kind of ugly. It'd be nice if you didn't see them, especially when you look through the side over here. You don't really want to have to see the joints. And if you pull the IK away from the FK controls, you can see those joints sitting around, which is distracting and a little bit strange. So unfortunately we can't hide those joints because the geometry is parented to them, but we can turn off the display in the panel. So you can do display show joints like that, and now we won't see those joints, which is cool. So you can tell your animators to do that. Make sure that in whatever views they're looking at, just tell them to hide the display of the joints. But the problem is that this doesn't hide there's two problems. It doesn't hide the joints for every panel, and once they've done this, they can't see their FK controls anymore because those joints are hidden. So what we want to do is actually add some FK control here for the joints so that if the animator does turn off the display of the joints like that, they can still pick the back controls. Okay, so let's go ahead and set that up. We're going to go ahead and create a just a NURBS curve, like a NURBS circle, to use for this. So we go to create NURBS primitives. I'm going to turn off interactive creation. Create NURBS primitives circle. There's the circle. Now how do we actually get this control, or this circle, to be the control that drives this joint? We don't want to actually parent the joint to the circle because we want to maintain the integrity of the joint structure, but we do want to use this circle to drive the rotation of the joint. Notice if we go to display shapes, you can see that a circle is basically a transform and then a circle shape. Every object that's geometry is like that in Maya. it's a transform first and then a shape which defines what it actually looks like. You get the same thing with the locator. See, the locator is a transform and then a locator shape that defines what the locator looks like. Geometry is a transform named HipGeo and then the shape that defines the geometry. But when you look at a joint, to go to the torso 1 anim, torso 2 anim, the joints don't have shapes. They're just transforms that are defined as joints. So what if we were able to take the shape of the circle and put that as a child of the joint, so that when I selected the circle, it would grab the joint itself. Just like how when you select the circle here, it grabs the transform. Maya understands how to do that. So if we could take the shape of the circle and make that the child of the torso, then we could use that circle to be the selection control for the torso itself. Luckily, the parent command has a way of doing this. So if we type parent add dash shape NURBS circle shape 1 to torso 1 anim, like so, look at what it does. It actually takes that NURBS circle shape, creates another version of it, and parents that to torso 1 anim. So if I go like this and select that shape, it actually selects torso 1 anim for me, which is pretty cool. Very, very handy. It's a little bit too big right now though, so I'm just going to go into wireframe mode, or sorry, into a side view here, go into component mode, and I'll select those CVs and then just scale them down so it's a little bit closer to the body. So there we go. Now we've got a circle that represents that. So we want to do the same thing for the second one, right? So we're going to do parent add shape NURBS circle shape 1 to torso 2 anim, like that. And you see we have another one. So if we go into wireframe or into component mode and start scaling this, you'll notice that it's actually affecting the other circle as well. The reason for this is when you do a parent shape command, it's actually creating an instance of the original one. So unfortunately, now we have two instances, one which is a child of the first one and one which is a child of the second one, and we can't modify them independently. So instead of just going ahead and doing that, what I'm going to do is select this NURBS circle, I'm going to duplicate it, delete the original so we don't have to worry about it, and then choose the command that we had before, which was parent add shape NURBS circle shape, and now it's going to be 2 to torso 2 anim. And now we can go ahead, scale this one down a little bit, and it won't affect the first one, like that. Looks like we need to scale it up a little bit more. There we go. Done. So now we've got two curves which we can use to delete this here, and we can select each of these, and then that will give us the FK control. If we go show joints, we don't see the joints, but we still see the FK controls, which is great. Now very quickly, just to make sure things are consistent, we're going to change the name of the shapes here to torso 2 anim shape, and this one will be torso 1 anim shape. Again, always good to rename to keep things as clean as possible. So along with our idea of being able to toggle the visibility of our controls on and off using this control, what happens if you're in a shot and you don't want to use the FK controls, you only want to use the IK controls? Or if you're only using the FK controls and you don't want to use the IK controls, you need some way of being able to toggle off the FK controls without affecting the IK. So let's go ahead and create a layer for just the FK controls. So we'll go to the layer editor and we'll call this FK torso layer, like that. We'll save that. And now in the memberships, we'll go to membership there, and because we don't want to take the IK control here out of the layer it's currently in, we'll just select torso layer, We'll open up the anim, go down to body anim, torso base joint, and then we'll pick torso 1 anim and torso 2 anim, like so. So now we've got the torso 1 anim control and torso 2 right there, so we can turn off the display of the visibility of the FK layers, which is great. We'll double click on this, maybe change the color to blue. You can use it whatever you want, but now you can see the FK layers are separate from the IK layers. But unfortunately, notice what happens when I turn this off. Choo, boop. The IK shoulders go away, which is no good. We need to make sure that they stay there. The reason they go away is because the IK shoulder control itself is a child of torso end joint. So if I turn this off, the whole thing gets hidden. So one solution for doing this is, instead of actually having this joint parented, or the group parented here to the shoulder end joint, we can just constrain it. So what we're going to do first is we need to tell the shoulder group, notice right now it's completely locked. We can't do anything with it because we have no attributes available. So we need to turn on the display of all these attributes. So if we go to channel control, we're going to take all of our locked controls here, and we'll unlock them first of all. Then we'll make them keyable. So we'll go to our translation and rotation, translate. Make those keyable, and we'll look for rotate, X, Y, Z. Make those keyable. We'll duplicate shoulder group, delete the child, and we're going to call this thing shoulder group pause. And we're going to leave it right where it is, so it's a child of the torso end joint. Then we're going to take the shoulder group itself, and we're going to parent it to the same place as hip group, so it's easy to find. So we know the hip group and shoulder group are in the same spot. Then I'm going to select the shoulder group position, shoulder group, and we'll go constrain, parent, like that. So now torso 2 anim, we'll move it, but when we turn off the display of the torso layer, the FK layer, we can still see the shoulders. So what we've done is we've said, okay, instead of having the shoulder group parented to the torso controls, we're going to duplicate the shoulder group, make another object here, which is going to be the child of the torso, and then constrain the original shoulder group to that one. So then we'll just go ahead and we'll lock the shoulder group translations, so the animator doesn't accidentally move that. And we're done. We can now turn on and off the display of all of the animation controls. We can turn off the display of just the FK. We can take the entire thing, move it around, like so. We can grab anim group, move that. Or sorry, not anim group. We can grab all anim, move that around, scale the whole thing, and it all is going to work exactly how we want. So we've limited our control selection. We've created a clean rig presentation. We've made a rig relocation program that works. We can move the rig around, and it all does what we want for the torso. So what do we actually do? Well, first we looked at reference. We figured out what was necessary for the entire torso rig to work, what kinds of controls we would need. We tested various solutions for it. We moved the rig around, we tried creating FK, we tried creating IK, we analyzed each of those solutions, and then we created a clean rig following our guidelines once we had them all sorted from testing. We tested the rig in the workflow to make sure that it worked correctly, and we delivered something to the animators that they were going to be happy with. Now what I would do at this point is go back and recreate the rig again using everything that we had figured out, but all the things we figured out by going through it the first time. You always learn a little bit here and there, so we recreated it again cleanly and then passed it off to the animators to get notes. So now that we've got the torso, the next thing we're going to move on to is the head. So why is the head the next thing that we're going to be looking at in order to create our control? Why not the arms or the hands or the feet or maybe the tailbone or an ear or something like that? Basically, because the body is the torso is the main thing that moves the body around. The head and its relationship to the body is what gives the character the attitude. You want to make sure that your character can connect with an audience. And a good way of doing that is making sure that while you're rigging up the character, you're rigging it in a way that the animator can really analyze the performance between the various body parts that are going to kind of influence the audience's perception of that character. So it's very hard for an audience to connect with a no-headed character. I don't know how many people you've had really intense dinner conversations with who didn't have a skull staring back at you. You know, it was, I mean, you've got to have something to look at. So for me, even though the head doesn't affect very many other body parts, like the torso affects the arms and the hands and the legs and the feet and the head, the arm itself will affect the hands and the fingers, which is quite a bit, but the head is really the attitude, and it's the emotional center of the character, which is why I like to focus on the torso and the head as the very first part of what we create. So, with the head, well, how do we determine what we need to be able to do? Same thing as everything else. We're going to look at reference and analyze motion and figure things out. So while we're looking at the reference, I want you to keep something very important in mind, that it's the relationship between the head and the shoulders that defines the attitude. So I want you to look at the relationship of how the head works in conjunction with the shoulders, how they actually operate together, and see what is necessary in order to create the type of animation and the type of believable emotional motion that we're going for. So let's bring up the first head reference shot that you've got in that comes with the DVD. This is one of Jason Osipa, and he's cracking up here for some reason. I'm not sure exactly why, he just is. And so if you watch this, and how his head and shoulders, not the shampoo, how they work together, you can see he's very squared up. He's staring straight at us, you know, square shoulders, square head, and then as he cracks up, you can see the kind of break in that, where the head drops down, the shoulders come up, and then the head turns to the side, and then kind of flops backwards and leans out over to the side, and then drops down. So what we can determine from that is that the head needs to be able to rotate and move around. In this next example, we're going to take a look at Carlos and what he's doing here on the crutches. As he's moving around, watch the interaction between what his shoulders does and his head does. When he bends down like that, the head rotates up independently from the shoulders and then rotates down. It's kind of moving inverse. So he goes from a curved shape like this, and then it goes out to a curved shape going that way. So you need to be able to rotate the head independent from the shoulders. And if you had to counter animate the head each time you were doing this, it would get very frustrating for the animator. Here's another good example. In this one, Bryce is running around, and notice how he fixates on this rock over here. Then he turns, sees another obstacle, dodges that, luckily, dodges another one, and then watch this. As he jumps and spins, the head moves with his body and then turns around and goes in front of him, and then continues off. So it seems relatively simple, except that he's doing a lot of things where he fixates on one object while his body's moving around and his head moves independent of the body. In this movie, we've got Carlos leaning forward, does a great little move here when he scoops the head forward and then scoops it up and pulls his shoulders back and then pulls his head straight back into his neck. Right here. He's leaning forward and then he goes like that and pulls his head back. And then in this section here, you can see he's got his head shoved all the way forward as far as it possibly can go. Just pushing and pushing and pushing. So based on looking at those movies and any other movies that you might create, there's some general head motion requirements that we can sort of look at and make note of and say, okay, these are the things that we need to solve. First of all, the head needs to be able to orbit side to side. You have to be able to look to the left, you have to look to the right, and really orbit around, making sure that you're not just looking up and down, but you need to be able to really look all the way to the left and all the way to the right. You need to be able to look up and down. You have to lift and lower the head. You need to be able to lean side to side, kind of do the dog, "Arr?" type look. What? You should also be able to move the head forward and backwards, as Carlos did when he was in the wheelchair, moving forward and back. The head can compress and extend. It's important to be able to bring the head down into the shoulders and then extend it out as you push up. And the head should be able to move side to side and do like the, basically move it around in a circle. Forward, back, side to side, in, down, up, down, left, right, etc. There's also a couple of additional head motion requirements that we discovered while looking at the reference. Your head should be able to orbit independent of the shoulders and body. In the example of Bryce, where he's jumping and focusing on different parts of the obstacle course he was running around, if we had to, when he was spinning, if we had to counter animate the head every time he twisted his shoulders in order to keep it locked on something, it would have been really difficult for the animator. But by being able to keep the orbiting independent of the shoulders and the body, then we can make it a lot easier to animate, and you can just add in the rotation that you want as opposed to having to remove rotation that you don't want. And the same thing applies for translation. It would be really nice to be able to lock the head down somewhere. For example, let's say you're pushing off of a wall and you want to lock your head against the wall. It's really nice to be able to lock that head there and push the shoulder and body away, just in case you need to be able to do that. Notice I'm saying here that the head translation should be in shoulder, body, or all space. What does that exactly mean? What does it mean to say it should be in a certain space? Basically, that means that the translation and rotations are going to be relative to another body part. Normally, the head translation is in shoulder space, meaning you move the shoulders and the head moves with the shoulders. It rotates and it translates and everything. It follows along the shoulder. If you say it's going to be in body space, what that means is if I rotate the shoulders, the head's rotation isn't going to follow. It will only follow if I'm rotating the body. Or if I'm in all space, I can rotate the body and the shoulders, and the head will stay where it is. And only move with the all space. That's basically all it means. By space, it just means in that other object's, basically it's going to follow that other object. It's almost like a constraint. It's just saying it's constrained to the body rotation, or it's constrained to the all rotation, except it's not constrained exactly because you want to be able to move the head independently as well. So what about the neck motion requirements? Notice here I have just do the right thing. A little secret that I'm going to pass on to you guys, it's important to realize, is that for the most part animators really don't care about the neck unless it's doing something wrong. We just really want it to do the right thing. We want to be able to bend it and move it and rotate it, but we don't really care. It's all about the head and its relationship to the torso. As long as the neck looks right, then it's doing the right thing and we're happy. What this means is it's really easy to rig for the most part. You just sort of make sure it's doing the right thing, but it's also really hard to rig because it's got to do the right thing. So it's almost more important that the head, because you're not going to be adding too many controls for the neck. You're not going to say, well, the animator will make it look right. You have to make it look right. Okay? So this is on most kind of general people. We don't really need to worry about it. If you have a character that's got a special neck that's really long, then you might need to make some extra controls for it. And the back rig that we made earlier works really well for creating a neck. But for this case, we're going to have a very simple neck control. So let's take a look at our head toolkit and see what types of things we're going to be using to make the head do what we want. One of the first things we're going to look at is constraints. Since we want the head to be able to move differently based on different options, whether it's going to be in the head or in shoulder space or body space or all space, we need to understand how we can use constraints to achieve those different options. Okay, so first of all, let's take a look at a point constraint. In a new scene, we're going to create 3 polygonal cubes. So create polygon primitive, cube, and then if I hit G, it's going to create another one and another one. If you ever hit the G key, what it does is just repeats your last menu item that you've done. Okay? So we've got 3 cubes here. We've got cube 1, cube 2, and cube 3. And what we're going to do is constrain cube 3 to cubes 1 and cubes 2. So to do that, select cube 1 select cube 2, and then finally select cube 3, and go constrain, point, and then look at the option box. Notice here it says constrain axes all, maintain offset is turned off. Click add. And what that does is tells cube 3 that it's going to follow cube 1 and cube 2 just the position. Notice it's not following the orientation at all. It's just doing a point constraint, saying follow the point of where that is and the point of where that is. And because we told it to do both, right now it's halfway in between. If we select p cube 3 and go over into our channel box and scroll down, you'll see there's p cube 3 point constraint. And here you've got p cube 1 weight and p cube 2 weight. Notice it says weight 0, weight 1. That's just the way the weights are named. They start with 0 and just increase. Right now those are both set to 1, meaning they both have a value of 100%, which means this is halfway between the two of them. If you set p cube 1 to 1 and p cube 2 to 0, and then select p cube 1, you'll notice p cube 3 follows with it the whole time. If I go ahead and scale this a little bit differently so you can just sort of see exactly what's going on, notice how p cube 3 follows with that. If we go back over here to p cube 3 and we change our constraint so that p cube 2 is set to 1 instead, it's going to follow that. And notice p cube 1 has no effect. You can even do more interesting blends. Like you could say it's maybe 40% of p cube 1 and 100% of p cube 2. And see how it affects that a little bit. So it's kind of interesting. You can allow the animator to blend that. But this is kind of a pain to go and change for an animator. And honestly, if I select this thing, animators aren't going to know to go down and look for a point constraint and then sit here and deal with all these different values to change in order to get exactly what they want. It'd be a lot easier if this was all done through pull down, where they could select what option they want just by selecting the cube and say, I want to be constrained to 1 or 2. Then wouldn't that be easier? So let's go ahead and give that to them. We're just going to add an attribute to p cube 3 that tells it what object to follow. So go channels, add attribute, and let's go ahead and call it constraint, like that. And we're going to choose a data type of enum. We have vector, integer, string, float, boolean, enum. Enum allows us to actually give it names. So the names we're going to choose, we're going to go to green here, and we're going to give it a new name, and it's going to be called p cube 1. Just hit enter. Go to blue, change that to p cube 2, like so. Then if we click OK and add it, notice over here there's a new constraint attribute and there's a pull down, p cube 1 or p cube 2. Right now these don't do anything because they're not connected. So we need to connect these up to the constraint itself. So if we go to animate, set driven keys, we're going to use a set driven keyframe method for doing this. There's multiple ways to set up this type of control. I like set driven keys because they're pretty easy to explain and they kind of make sense as you start going. So what we'll do is with p cube 3 selected, we're going to load the driver and we're going to say that the constraint is going to drive this point constraint. So we'll choose load driven by clicking on point constraint here, load driven, and we're going to drive these two weight values. So when p cube 3, the constraint is set to p cube 1, we want p cube 1 weight to be 1 and p cube 2 weight to be 0. And we click key. Then we'll change this to p cube 2, and when that's set to p cube 2, we want that one to be 0 and this one to be 1. And key. Now I can just go back and forth, p cube 1, p cube 2, p cube 1, p cube 2. And it doesn't matter where this thing is, I just select it, say no, you're going to follow p cube 1, and it snaps over there and follows that one. So you can tell it's a lot easier for the animator to work this way. They select the object they want, they say this is the thing I want you to follow, and it'll follow it, which is pretty cool. You can have as many of these as you want. You could say you could have 47 different types of connections for them to deal with, and the animator can pick them and save a keyframe, and it'll work just fine. Much easier than having to hunt and peck and find that point constraint value and know what to set. But this is cool, but the problem is that the object jumps every time they set a different control. So if the animator doesn't want the object to jump, this can be a real pain, because then they have to make sure this object is in exactly the same place as the other object, and then when they pass it, they may find a little jump. And so it would be a lot better if, like the pivot control, we had a script that would set up that would allow us to switch the parent or switch the constraint without the object jumping. So we're going to get into this a lot more in course 4 of the Animator Friendly Rigging series, but I will show you a script that allows us to do that right now. So included with the DVD are a couple of scripts. There's a JS setup multi-constraint.mel, setup multi-constraint-ui.mel, which is the basically a command, a UI to set up the multi-constraint.mel command, a snap object to constraint, which will snap an object to a new constraint, and a UI to build that script. Okay, so let's go ahead and create a new scene, and we'll set this up. We're going to create 4 polycubes, so we go create polygon primitive cube, and we'll hit G 3 more times. So now we've got 4 polycubes in our scene. Then we're going to create a locator, which will be used for controlling this constraint. So create locator, which is just right there. And then we're going to set up the constraint. So if we click on this button here, this is the setup the multi-constraint UI button. Alright, so we're going to pick pcube1 because this is going to be the object that we want to constrain. And I'll click load selected. Then I can pick all of my target objects, which are going to be 2, 3, and 4, and add those right in here by clicking the little plus. Then we can set up the type of constraint, so we'll have point and we'll have orient. Then we can select the locator, which is going to be the control object, and we're going to name the attribute constraint, like we did before with the add attribute, and then just click apply. Now if we close this, you can see what's happened is that we've created a constraint, or an attribute called constraint on the locator called pcube2, and there's 3 different options here, pcube2, pcube3, and pcube4. You'll also notice that pcube1 is now underneath a group called pcube1 group. And what's happened is that group, let's turn off the display of shapes so this is a little easier to see. That group has been duplicated, and a duplicate of that group has been parented underneath pcube1, pcube2, and pcube3. So that if I grab pcube2 and move it, pcube1, which we will scale so we can see what's going on, is going to follow pcube2 because pcube1 group is constrained to pcube1 target pcube2 group. There's also the same thing underneath 3 and underneath 4. So if we select the locator and we switch to 3, you can see it snaps to 3, and pcube3 will move over there. If we select that locator, change this to 4, it snaps there. So just like before, we have 3 different settings here where we can go ahead and animate. Now the reason why we're using a group node over cube1 is so that we can then take pcube1 itself and animate it independently of the constraint. So we don't have to worry about basically, like, we don't constrain this object itself, because if you do and then you start setting keyframes on it, you'll break the constraint. So this way the animator can animate this guy independent of what object it's constrained to. Now this still has the same problem as before, where as soon as you switch what object it's constrained to, it snaps. Notice, like before, snap, snap, snap. That's where this script comes in handy, the constraint snap UI. If I turn this on and I have the locator selected, what's going to happen is it'll tell me what object is constrained, and I have an option here for no pop snap on or off. If I have that on and I switch to pcube3, watch what happens. The object stays over there, but it's no longer constrained to pcube1. It's now constrained to pcube3. If I now switch this back to pcube2, see how it's not snapping, it's not popping? pcube4, it follows that. So this way we're giving the animator the ability to switch what is the parent and it's not snapping at all. What this is doing is basically going in, looking at pcube1 and saying, okay, what value do I need to set on you in order to make this happen? So if I'm on frame 8 and I'm a child of this object here and I go pcube2, what it does is on frame 7 it saves a value at the position, and then frame 8 changes the constraint so it's going to follow this object now. Okay? Very handy, and we can use this on the head to allow the head to change its orientation based on either the shoulders or the body or the hips without any snapping going on. Very, very cool. So now that we have an idea of how to hook up the head space manipulation in terms of whether or not the head might be in the neck space or the body space or the L space or whatever, let's take a look at what types of controls that are necessary for the neck rig. As I mentioned earlier, the neck is one of those things the animators really doesn't want to think about. What they want is for it to be pretty much as automated as possible. You take the head, you tilt it, and the neck does the right thing. It goes from the shoulders to the head, and that's what it needs to do. So, because of this fact, it's important for us to make sure the neck control is relatively solid. I like to use a rig that's similar to the back control, but with a few modifications to make sure that the base of the neck doesn't bend too much and that it doesn't pop and snap and jump and do all sorts of crazy things that you don't want it to, because if it did do it, then the person's neck would look crazy. So, let's take a look at an example. In our new Maya scene over here, we're going to go ahead and create a fake little neck. Let's go to a side view. And we'll go to the skeleton tool, choose the fantastic joint tool, and we'll click right at 0, 0, 0, and then go up here to about 0, 3, 0. And I'm just going to change the scale of the joints here so you can see what I'm doing, because those are a little bit tiny, a little too small to tell what's happening. Yeah? Yeah! Okay, now here's our neck joints, and we're going to split these into 3 segments. So I'll click on the little split selected joint tool, segments 3, and that's done. I love that tool. Okay, now let's go to our spline IK so we can create a similar spline IK system that the back has. So we go to skeleton, IK spline handle tool, display our outliner here, click on joint 1, and then control click joint 2, and we get the IK handle 1 and the curve. And we have our curve that when we go into component mode we can pick and move around, and it does that type of thing. Sweet. Okay, now we're going to create our joints that we're going to use for skinning, just like we had with the hip joint and the shoulder joint, and then we skin them. So we go skeleton, joint tool, holding down X for grid snap, boink. I'll create a joint right there. Then I'm going to hit Y, which will complete the tool and then re-enter me into the tool, and then create joint 3. And then, so now we've got joint 3 and joint 4, and let's go ahead and smooth bind them. So we'll select the curve, select the joints, and go skin, skin, smooth bind. Just like that. Now as I move joint 3 around, you can see it pulls the skin, move joint 4, and it pulls the skin. The next step is to make this a stretchy spine. So we will select the curve, we'll go over to our Create Stretchy Spline button on the shelf, click on that, and we'll just leave the maintain volume off. We're just going to leave it as NURBS curve. Click on that. Now as we take joint 3 and joint 4 and move them, you can see that the joints stretch to match the length of the curve. One thing you'll notice though is that as we drag joint 4 or the top back and forth, see how the base here rotates quite a bit? We don't really want that to happen, because if you imagine that this is a character's neck and you pull their head forward like that, the base of the neck is going to bend a lot, and we might want to reduce that. So let's take a look at a way we can reduce the bending of the neck. But first let's see why it's doing that. So if I select the curve and I go display, NURBS, CVs, you can see the points, the CVs of the curve. If I then pull this, we take a look at what the CVs are doing, you can see there's one here at the base which is always staying locked, and one at the end which is staying locked. Then there's this CV here which is somewhat attached to this joint and somewhat attached to this one. Mostly it's getting a percentage of this joint, and this one which is mostly getting a percentage of the base here. And so as we move around back and forth, you could kind of see how the CVs are moving. If we were to do something that would allow the base to get more weighting of this top CV right here, that would cause the curve to not bend as much forward with the base or with the top of the neck, which would allow us to keep it from bending too much at the base. So let's take a look at a way of doing that. If I go back to the skeleton joint tool, I'm going to create a joint right down here at the base, and then we're going to select joint 5 and the curve and go skin, edit smooth skin, add influence. And what that does is joint 5 now influences the curve just like how joint 4 and joint 3 do. And if we take joint 4 and we move it, you can see now that because of joint 5's influence, we get less bending at the base. This doesn't go quite over as much, and we get a much more natural feel to the whole thing, which is very nice and very handy. But we want to make sure that when we take joint 3 and we move it, joint 5 moves around with it. So we'll just parent joint 5 directly to joint 3, and now we move that, and we get the base moving. We take the end, and the end moves. Cool. But let's see what happens if we were to take, imagine this is the head of the character up here, and these are the shoulders. If we're to take the head and kind of scrunch it down, watch what happens. See how the curve, the joints start to flip out as it gets too close? I'll pull it over to the side so you can see. This is because of what's happening with the CVs on the curve. They're staying, especially this one right here, is kind of sticking up like that. And as they bend over, they start to kind of collapse, and the curve starts to get funky, and it's curving too much for the joints to know what to do. So the whole thing starts to kind of explode and look bad, which we don't want to have happen. We want the neck to always be clean and look nice and be very easy to see what's happening and not pop and explode. So what we want to do is somehow tell the neck that as it gets shorter, to not do that, to just sort of scale down. So it's kind of similar to what we're doing with the curve here, getting the arc length and scaling these joints, except that what we're going to do is look at the distance between the top joint and the bottom joint, and as they get close, we're going to take this bottom joint here and we're going to scale it down like that until we get a very nice clean neck. So let's see how to do that. First thing we have to do is create a distance tool so we can measure the distance between these two. So we'll go to Create, Measure Tools, Distance, and then I'll click down at the bottom, click at the top. And we get two locators. We get locator 1 and locator 2. And what we want to do is make it so that we move joint 4, that changes the position of locator 2 to be at the end of it. So it will follow along, which will change our scale. So if I take locator 2 and I parent that to joint 4, just like this, now when I move this around, you can see the length is changing. We get that distance node changing. So what we want to have happen is as the distance gets smaller and we go down like this, joint 3 will scale down and cause the neck not to pop. Okay? So to do that, we're going to take joint 3, going to go to the scale attributes here in the channel box, right mouse button, set driven key, and then we'll choose our distance dimension shape, load that as our driver, scale all the way or scroll all the way down to distance, and then say at 3 these are fine, so we'll key that. Then we'll go to joint 4, translate it down to around here, and you can see that the curve or the joints aren't doing what we want. Select joint 3, scale that down to about there, and key that. Now we'll go back to joint 4, and now notice that as we move this guy around, especially you can see when we're far over here, see how joint 3 starts to scale, and it keeps the whole neck from popping and freaking out. Pretty nice. Very handy. So now that we have an idea of what our head toolkit contains, we can go ahead and get our animation requirements specified for the head and neck. Basically, we need head translation and rotation so the head can move around and rotate and orbit in any direction. We need the neck to be able to follow the motion of the head, and we've got space switching that we need to do. So let's go ahead and start creating the neck rig. Alright. And when we work on the head control, let's remember that there are some things that we need to make sure that the animation controls have. We got to remember that they have simple controls, the animation is easily transferable, the controls should be unique and understandable, they have to have the correct rotation orders, they should be named correctly, and we can have limited, or we should have limited keyability, not limited liability. I'm not your lawyer telling you what you need. You need to restrict your limitations of your liability if the animator keys things wrong. Anyway, let's go ahead and start creating the rig. So go ahead and open up your latest version of the rig here, which should be the back. That's all working nice and handy and looking good. And what we want to do is show the head and everything that's related to it. So if you go into your little JJ group here and go ahead and just show those bits, we'll show them like that, and we'll grab the head and we'll show that. Collapse that. We've got the head geo, we've got the eye groups, we've got the hair all grouped together. Let me turn off the display of the shapes, and the brows and everything. If we go into shaded, textured, you can see the eyes right there. Let's just go ahead and group all of these together, select them, Control G, and we'll call it head group, just so we know what it is. And then make sure that the rest of JJ is hidden so we don't have to worry about them. Alright, so in order to make the head rig, you'll notice that right now the head and neck are all one piece. And what we need to do is sort of dice up the head in a good place in order to rotate and differentiate between the head itself and the neck. So where is a good place to do that? Well, if we go to a side view, we can start to look at the head and figure out, well, what is head and what is neck? And where do we want to pivot from? Well, a good idea is to actually pivot from right around here, so that when you tilt the head back, the ear goes down, but the head goes up. It's kind of like if you feel on your own head where you pivot from, and you rock back and forth. Just look up, look down, look up, look down. You'll notice that your ear goes down. If you look up, your ear goes down, your face goes up. If you look down, your ear goes up, and your face goes down. If you put the pivot back over here, and everything rotated around that point, it would feel like you've got your head resting on something and you're lifting it around. But if you're just moving your head normally and you're isolating it, so just that head joint without the neck, this is about where you want the pivot to be. Okay, but given that that's where you want the pivot to be, we've got to break up the geometry to make sense along that axis. So if we were to follow maybe a line like that, that would give us a good idea right along here. That would give us what we want in order to break the geometry. But the geometry itself doesn't really follow that line, so we need to segment it and make it look right. But in order to make sure we segment it in the correct place, let's go ahead and create a joint that's going to give us exactly the rotation or the location of the pivot. So we'll go and we'll click about here. Make sure we're turning on the display of joints. Otherwise that's going to be a bit tough. And let's change the scale of this joint. A little bit too big. Like so. And we'll put our next little joint right around there. I think that's going to be where the pivot will be. Right there, looks good. So the flow of the polygons through here doesn't quite line up to what would be a good location to split this. So let's just go ahead and split the polys. So if we go to our modeling tools, polygon, and we'll choose edit mesh, split polygon tool, and then we'll just sort of start cutting these points. So we'll grab that one and then maybe continue on up through there, and then you can see that we get a little bit of a flow going this way, but we need to edit this point right here. So we'll grab that, translate it up, and now we've got a flow that goes straight from the front of the neck all the way back over towards where the pivot is. But that's only on one side of the geometry. If we check on this side, you can see that we are missing the split through here. So we'll just create that as well, there to there, and then right on up to here. And there we go. We've got the split that goes all the way across. So let's go ahead and select all these faces now so we can separate them. So we'll go to a side view, go into component mode by hitting F8, and then click on our little face selection. If we go into wireframe, we can then just go ahead and pick our lasso tool and kind of go around and select a bunch of these points, like so. Go into perspective and make sure we get these ears. You got to get the ears. Otherwise it's going to look really weird. Make sure we grab that little piece right there. You can see the line that we're going for now. Underneath, it's all picked. This one, grab those guys. And there we go. Oh, except for that piece. Got that one. Alright, so now we've got all the pieces for the head, all selected. And we'll choose the mesh, extract, and let's just go to the option box to make sure that everything is correct. Want to make sure we separate the extracted faces. Extract that. And now you can see that we'll have two different pieces, the polysurface 1 and polysurface 2. And we'll basically have the head and the neck. So let's edit or delete the history. So edit, delete by type history, because we don't need that on the head. And we're going to rename polysurface 1 to head geo, polysurface 2 to neck geo, and then just for this, head geo group. Just to make sure that our naming scheme is all correct and nice and lovely. Now normally our next step would be to segment out each piece of the neck so that when we pull the head forward it'll bend and move correctly. But look at what happens if we actually do that. This is an image of where I tried that, where I separated the neck out into individual slices for the joints, and notice that as you move the head forward, it pulls apart and you get this huge gap right here in the neck. That's from this to that. This can be really distracting for the animator. I mean, you basically will move around with an opening that's bigger than the mouth. And even though it's down at the base of the neck, if you kind of blur your eyes, you get confused and it almost looks like he's happily opening his mouth. Imagine you try and make a little subtle happy shape with the face, and then you get this huge opening here. It just looks really, really strange and really bad. So even though it's good to segment geometry so the animator can move around as quickly as possible, you don't want that segmentation to be distracting. What you really want is to make it so that this doesn't distract and the neck isn't distracting, and the things you do don't disturb the animator more than help them. So instead of actually doing this, we're going to end up skinning the neck. But we'll go ahead and get to that in a little bit. The first thing we want to do is create the head controls themselves. Since the first thing we're going to do is create a head control for the character, we want to come up with a design for our icon that makes sense. We can use, again, things like arrows and curves and circles and stuff. But because the head is kind of oddly shaped, I'm just going to create an icon from scratch. So we'll go to our side view here, and we'll choose the Create EP Curve tool. And then we're just going to create something that's roughly the shape of the head. Or you just sort of click around, jink, chunk, boink, like that. And that gives us a nice looking head control that follows the shape of the head and is easy to pick. But right now, because we just created this curve, the pivot is down over here at the base. And what we want to do is have the pivot up here at the base of the head, not down over there. That's sitting at the origin. So to do that, we can either choose the Insert key, or Home if you're on Mac, and move the pivot up this way, and then try and zoom in and kind of snap it right there, which can work just fine. Or you can use a script that comes with the DVD. Let's get out of insert mode here. This is the copy pivot icon that's on your shelf right here. So what you do is you select joint 2, which is this child joint here, and we select the curve and click copy pivot. And what it does is it moves the pivot of the second object to the location of the pivot of the first object. Much easier than clicking insert and doing all that stuff. So we moved the pivot. And of course we want to change the name of curve 1. We'll call it head anim, because this is the animation control. And we've got all the head bits kind of grouped together. We're going to ungroup the neck geo for now. We've got head group. We're going to take head geo and we'll just unparent it to there and delete head geo group because we don't need to worry about that. With the head group selected, what we're going to do is make sure that the rotation orders for the head anim and the head group are all the same as they are for the shoulders and for the body. Because again, we got to make sure all this stuff lines up. So if we remember correctly, we go to our shoulders, and we check in our attribute editor, and we can see that the rotation order is ZXY. So we'll select head group and head anim, and we'll go to our animation tool, and we'll choose our rotation order tool, ZXY, set those rotation orders. And we also want to make sure that the head group is in the same position as head anim. So we'll select head anim, then head group, and click the copy pivot. And now head group is in the same place as head anim. And then we'll simply parent constrain the head group to head anim. So select head anim, select head group, go back to animation mode, and choose constrain parent. And now with head anim, we can move it around, and the head follows. We rotate it. Our rotation orders are all correct. And there we go. Pretty easy, right? Setting up this type of control is not too tough. But we got to make sure the neck does the right thing, because now when I move this, you can see that the neck isn't following correctly. So what we want to do is get the spline IK working for the neck, and then get the skinning happening correct. So we'll go to a side view, and we're going to break the neck joint itself up into 3 different segments. So I'm going to select this joint, and we'll choose our segment tool, make sure it's broken into 3 segments, just like we had before, and we're going to rename the neck joints themselves. So the bottom one is going to be called neck base joint. Notice how I'm always using the term base for the bottom. And then these two, we'll select these, choose the hash rename, and we'll call them neck hash joint. So that's neck 1 joint, neck 2 joint. And then this, neck and joint. Something I like to do always, base at the bottom, end at the end, and then numbered in the middle. Don't know why I like that. I just think it's awesome. So that is what I use every time, because it's my favorite. Alright, so then we'll choose the spline IK tool. Skeleton IK spline handle tool, neck base joint, neck end joint. We've got our IK handle and everything. So notice that because we've practiced this stuff, it's a lot easier to go through and figure out how to do it, and we know exactly what we're doing. Name this neck IK handle. Change the name of this curve one to neck curve. And then remember, we want to set up the advanced twist controls for the IK handle so it does the correct thing. So we're going to bring up the attribute editor. We'll scroll down to the solver attributes, go down to advanced twist controls, enable them, set it to object rotation up, start and end. And this is exactly the same as what we have set for the back. So we'll slow down, or we'll scroll down, and we're going to choose a up axis that we want to use. So right now, which up axis do we need? Well, let's take a look at what the joint is. We select neck base joint, display, transform display, local rotation axes. You can see that Y is the default going that way. And remember, going back behind him is up. So we'll go to our neck control, and we'll choose the up vector of positive Y, and the up vector, or sorry, the up axis of positive Y. And then the world up object and the world up object 2 are the 2 things that we're going to be aiming this along. And the up vector is going to associate with world up object. Up vector 2 will associate with world up object 2. World up object, which is the base, is going to be shoulder anim. World up object 2 is going to be head anim. And because those point along the negative z axis, as you can tell down here, negative z going that way to align with going backwards, we'll set that to -1 and that to -1. Just like that. So that now if we take this guy and rotate it, and this one and rotate it, the neck will spin correctly. Let's turn off the display of this guy. Display, transform display, local rotation axis, so we don't have to worry about that. And now we want to create the joints that we use to control the neck curve. So go back to our skeleton joint tool, holding down V for point snap. I'll create joint 1 right here. Enter the tool again, V for point snap, joint 2 right there. Actually, I forgot about adding that extra little joint right in here to take the weighting. So let's undo that, and we'll do it again. Joint 1 right there. And then we'll while holding down V, we'll keep going over here until we get to that position. And again, this is going to give us that joint that aligns here that keeps the neck from bending too much. So we've got joint 1 and joint 2. Then we'll come over here to joint 3 and create that one. Then we'll take all of these and the neck curve, and we'll go skin, smooth bind, like that. And now joint 3, as we move it around, you can see we'll bend the neck. Let's go ahead and rename these joints. So we've got joint 1, we'll call this neck, curve, base, bind. Then neck, curve, 1, bind. And we'll call this neck, curve, top, bind. You can really name them whatever you want, but this seems to work pretty well in terms of now I understand exactly what these are for. We'll go to the neck curve and we're going to add the stretching. So we're going to click on this tool. Make sure neck curve is the curve that we have selected. Maintain volume is turned off. We're going to turn on world scale. And what this does is, remember before with the back how we had to add that expression to make it so that when you scaled the whole character it wouldn't blow up? This world scale automatically does that for us if we turn that on, and then we tell the node that we're looking for all anim, and as soon as we enter that, it'll give us a list of all the attributes in here that we can connect to. If we scroll down, you'll see that global scale is on there, because remember, all anim is the node that controls the entire character. Global scale is the one that scales him. So we'll click apply, and that's automatically going to add that expression, that item in the expression there for us. Now if we move these guys around, take the top one and move it, you can see that the curve will stretch with it. So we'll now just go ahead and parent these correctly. We're going to take neck curve top bind, and we're going to parent it to the head, like that. So when we grab the head and move it, that moves around. We got to make sure that the base of the neck moves with the shoulders. So we'll take that, and we're just going to parent it to the shoulders. So when we move these guys, the neck bends correctly. But you can see that as we're moving this, the geometry is not moving itself. So we need to go ahead and skin the geometry. To do that, we're going to select the neck base joint and the neck geometry, and we'll choose skin, smooth bind. Go to the option box here. Make sure that we have the joint hierarchy is our bind to method, and click bind skin. And now, as we move the joint around, you can see that the neck follows, but it still doesn't do that great of a job. We still get that huge gap in here, which is very distracting. I mean, seriously, that looks like he's smiling. He's going, "Gah!" And there's his, like, I mean, if you go like this, it totally looks like he's just going, "Duh," which is not what you want. So we need to fix the skinning to make it so it doesn't look quite as, well, what's the proper word? Crappy? Maybe? Quite as crappy. What we'll do is we'll create a couple of influence objects to make it easier, because you notice as we pull up, we really just want the neck to attach to the head. And then the same thing there, we just want it to attach to the base of the neck. We don't, or to the shoulders. We don't need it to kind of do anything fancy. So we're going to create some influence objects. And to do this, we're going to keep it pretty simple. We're just going to create some cubes. So we'll go to create polygon primitives, cube, like that. And I'm just going to position these right around the top of the neck and at the bottom of the neck. So I'll scale that one down, and then maybe go over here to the segments. Actually, let's go ahead and orient it a little bit better first, so it kind of fits a little closer to what we want. Down like that. And basically what I'm trying to do is just surround that cut of where we segmented the head and the neck, like so. Maybe scale it down a little bit more. Go to a front view and make sure that it's scaled out enough to cover all that. Looks kind of like an Elizabethan collar. It's like, "Hello, hello, doctor. How are you, sir? Yes, yes. Let's go to our subdivision depth. Maybe increase that by 2, so we're up to 3, and then we'll position these guys. Go into component mode, make sure we're selecting the vertices, and then we'll just take them and move them like that. Take this one, and we're just sort of aligning it with that back, or with the cut, like that. You don't necessarily need to do this, I just like to, because then when I look at the geometry I know exactly what it's for. Otherwise it could be a little bit distracting, right? And then let's shape it a little bit more for the neck. take the front guys, these ones, scale them in like so, and maybe the back ones will scale in just a little bit as well, like that. Cool. So there we've got that for the top. Now we want to do the same thing for the base of the neck. So go to side view, go create polygon primitives, cube, move that to there, go into wireframe, scale that down, scale it in this way, rotate it, move it up to about there, maybe scale it down a little bit more, just get it close, like that. Take a look at the front view and see what that looks like. Pull that in a bit. Cool. And then we'll rename these. We'll call this one neck top inf for influence, and then neck bot influence or neck base influence, whatever it is that you like. And we'll select these as influence objects, which means they're going to influence the skinning that we already have set up. So if I select this geometry and then select the neck, or select the neck, select the influence object, and go skin, edit smooth skin, and we're going to choose add influence. Boink. Just like that. So if I move this geometry, you'll notice now that it's actually moving the neck like that. We'll do the same thing for the bottom. Skin, edit smooth skin, add influence. That will affect the base of the neck, which is going to be very cool. And we want to then parent these correctly. So we'll select the neck top influence, parent that like so. Select the bot influence, parent that like that. And then we're just going to hide these guys because we don't need to see them. And now let's see what happens if we go to a side view here and grab the head and start moving it. Well, the neck is definitely attached better, but it still looks kind of funky. It's not really very smooth. So we need to adjust our skin weights to get exactly what we want. And to do that, we want to make sure that the top row of pieces here are completely attached by the influence object, and the bottom row is completely attached to the bottom influence object. So all the other vertices should be smoothly deformed based on what they've been assigned to. So let's go ahead and select these bottom vertices. We'll go into component mode and choose our lovely lasso tool, and we'll just select, make sure we don't get any vertices that aren't along the bottom. Okay, we got all those. And then we're going to go to our component editor, which will allow us to modify the values specifically and make sure that we get exactly the values that we want. So we go in here, and notice up at the top there's a bunch of tabs. So if we go to the smooth skin tab right there, and you can see all these different values. What we're going to do is go to the neck bot influence right there, select all of these, make sure those have a value of 1. Doink. I want to make sure they're all 1. Woo. 1. There we go. Now those all have a value of 1, just like that. Then we'll do the same thing with the top. We'll go back to our selection tool. We'll grab all these top ones, like that. We'll find neck top influence. Scroll all the way down, get them, set them to a value of 1, like that, which is exactly what we want. Now, we'll close that, and we want to smooth the inside weights. So we're going to select just those guys. Make sure neither the top nor the bottom are selected, just the inside ones, like that. And we're going to choose the skin, edit smooth skin, paint skin weights tool, and bring up the option box, like that. And what this will do is tell us what points are specifically selected here and for what the influences are going to be. So if we go into shaded mode and we go over here to our neck top influence like that, you can see what's affected and what isn't. And we'll click on smooth like that because we want to smooth these values, and then we're just going to flood it a few times. Boom, 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 like that. And it should only affect the joints that we have selected there. Okay? Then we'll go ahead and select the bottom influence, and we'll flood that a few times. Dun, 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 like so. And what that does is that just sort of smooths the weights and floods them between the top and the bottom. So if we now go ahead and select this and move it, you can see that we get a really nice deformation on the neck. Very smooth and very clean. Now obviously it'll do some things that break like that, but again, this is just low res. This is for animation purposes, and our goal here was to make something that is not distracting. We don't want the animator to be like, what is the neck doing? So as we move it to the side and do this, we don't have to worry about the neck being super distracting. Okay? Cool, let's set our rotations back to 0. Sweet. Now the last thing we need to fix on here is, of course, our FK neck flipping. Now you might be wondering, why did we add an FK neck in here if we're just going to do the smooth skinning? Well, for the animation rig, we're doing smooth skinning so we can see it and make sure that it moves correctly. Once you actually get your muscle rig or your actual skinning rig in there, you will probably want to use these neck joints to help get the neck to do exactly what you want. So we need to make sure they behave correctly. Even though we're not using them for our animation rig, you will be using them for your skinning rig. So again, we want to create that distance tool between these and do that whole thing where we scale down to make sure that it moves correctly. So we'll go create, measure tools, distance, and we'll hold down V for point snap, put one down at the base there, one down over at the neck, make sure that they're in the right spot, which they are. Cool. And then we're going to rename them. So locator 1 here is going to be called neck length bot, and this will be neck length top, like that. And then instead of using a expression for handling the world scale, because we do need to make sure that as these scale, remember the same problem with the neck before and with the back, if you scale the entire geometry up, this thing, because we're measuring the distance, it's really important to make sure that it works correctly. Instead of using an expression to do that, we're going to use a multiply divide node to hook it up. So let's go ahead and select our neck distance. Actually, let's call it neck distance, like that. We'll select that and bring up the hypergraph. So go Window, Hypergraph, Connections. And you can see here we've got the neck length top shape locator, bottom locator, going into the neck distance shape in order to give us this actual distance here. And we're going to go to Rendering, Create Render Node. And then in here, we'll click on the Utilities tab. And if you scroll down, you'll see Multiply Divide. So we'll add that. And what this lets us do is multiply two values together or divide two values and get a result. Hence the name Multiply Divide. And we're going to call it the Neck Normalize node. So if we bring it up here, choose Rename, go Neck Normalized Scale, like that. And we want to add our all anim control here into the hypergraph because we're going to be using that. So if we click on it in here and we drag with the middle mouse button into our hypergraph, that will add it in here for us so we can work with it. So we've got our head anim. Sorry, we don't want head anim, we want all anim. Not the head anim. We can move the head anim away so we don't have to look at it. So we've got all anim, we've got neck top, neck bottom, the distance, and we've got our multiply divide node right here. So what we want to do is connect the neck distance shape and all anim to the neck normalized scale. So we'll take this with the middle mouse button and drag it right on top, and this will bring up our connection editor, where we can turn on the display of non-keyable nodes on the distance shape. We're going to scroll all the way down, and we'll connect the distance. And we're going to choose the input 1 of the scale node, our normalized scale node, which basically says the distance is going to be the first input there. And then we're going to take all anim, and we're going to drag that on top. And we're going to look for that global scale right there under scale, global scale. And we'll have that connected to the input 2x. Boink, like that. Then, if we select our normalized node, bring up the attribute editor for that, you can see that we've got one input is 0.291, which is the distance. Input 2 is 1, that's all anim global scale. And our current operation is multiply in order to get the value out of that. But we don't want it to be multiply, we want it to be divide, because we want to divide these two. So we set to divide, and then what we want to do is use this to be our driver in the set driven key thing for the neck length. Instead of using the actual distance node itself, what we've done now is we've now normalized the distance based on what the all scale is. See how that works? So let's go ahead and parent our locators correctly. So if we go ahead and take the neck bottom, we want to make sure that that's parented to the same place as the bottom of the neck. Parent that to the shoulder. We'll take neck length top, parent that to the head. So we've got that. Now, as we move the head around, those things will move and change the scale that we can see. So now we want to affect the scale of this bottom neck joint right here, neck base joint, which we should also parent. Whoop, there we go. So that as we move this around, see how the joint follows? We want to scale that neck base joint here. So open up our shoulder, choose our neck base joint, which we'll be changing the scale of. Actually, I'm sorry, we'll be using the neck base spine. That's what we're going to be scaling, not the neck joint itself. And we'll right mouse button over that, and we'll choose set driven key. And again, instead of the actual get to the distance node, instead of taking the distance, we'll bring up the hypergraph again. And we want the neck normalized, not the distance. So we'll use that as the driver. We're going to choose the output x because that's going to be the value that we got. Like so. And we'll say key that. Then as we take the head and we move it down like this, we'll grab this guy, scale these to like 0.1 or something, hit key. And now if we take this, you can see that we get actually a really nice deformation on those neck joints. Now, one of the problems is that where is my default? Where's 0? Well, luckily, because the way we had the character set up, when you set the translation X, Y, rotate Y, and everything else to 0, it puts it back to its default. This is why it's really important to make sure your controls can be zeroed out. If there was some value like translate, if you had values like this and that was your default 0, the animator would never be able to go back home, and neither would you when you're rigging it up. So always make it so you can set to 0, like we've done. Cool. Let's go ahead and save where we're currently at as a work in progress and continue on. So the next thing we want to look at is a little bit more control of the neck. Personally, when I animate, I'm more than happy to use just the rotation and translation of the head like that to control where the character is, because you can do things like lean them back, just rotate it, or translate it, rotate it, and you're done. You can then go and pull the head in, so it's like, what? You can do push him forward, and and he's walking and kind of bob his head back and forth. You can go ahead and do the whole, if we put that back in, you can pull him into the shoulders pretty easily. You can kind of do the side to side. I don't think so. That's right. You know, you can do pretty much everything you need to do, and it's really easy to get nice, subtle motion with it. But some animators really like the control of being able to bend forward, bend backward, etc. So, luckily, the neck, because it's set up the same way as the back, we can add this pretty easily. All we need to do is create an FK joint chain right in there, and it'll do it. So, but because it is a neck, we want to make it a little bit easier on us to work with. We don't need 3 controls or two or three rotation controls for the neck. We just need the one. So we're going to go ahead and create an FK control for the neck that's going to follow along. Okay? Let's just go ahead and create the neck joint. So we go skeleton joint tool, and then just as before, we're going to hold down point snap by hitting V and going to where the joint is, and then we'll hold down V again and go to the very end, boink, like that. Now we've got a joint. Check in 3D, make sure that it's right along that axis, which it is, and we're going to rename this joint to neck anim, like so. Now the next thing we want to do is rename the other joint, neck anim end joint. And we're going to parent neck anim to shoulder anim, just so it follows along with that, because we don't want to make it so that whenever we move the shoulders that the neck doesn't follow. So we got to make sure that it follows that. So that's neck anim right there. Cool. And now the next thing we want to do is set the joint orient. So again, what that means is we want to make sure that when we bend the neck, we have the same rotation axis doing the bend that is on the head, and that's on the shoulders, and that's on the body, and that's on everything. So remember, we're going for like total consistency here, where every time we bend something, it's going to always be the same axis. This type of consistency is great for the animator because it makes sure they understand exactly what to pick, and it's just so much easier. So if we display the local rotation axis for this joint, like that, we can see that Y is pointing back, X is pointing down, and Z is pointing along that axis. So what we want is right now, rotate X is twisting the joint instead of bending it forward, like is happening on this control. So again, we'll display the transform axis, local rotation axis on that one. And we want Z on this joint to point forward, Y to point along there, and X to point out. So how do we do that on here? Skeleton, orient joint, option box. Since we want Y to point down along there, we want to make sure that Y is the first one in the orientation, so it's either YXZ or YZX. And then we want the second axis to be positive X, and we'll click orient, and there we go. And so now, if we take both of these controls and rotate them in X, they both move exactly the same. Consistency, man. That's what it's all about, is being consistent. Alright. Consistency. C-O-N, consistency. The next thing we want to look at is the rotation order for this guy. Now, the rotation order on these and on the head is a little bit different than what we want. Because the head and shoulder controls are basically regular controls of transforms, and we want Y to be the first thing that goes, so that when you rotate like this, all the other axes follow. On the neck control, when you're using FK, you want the thing that twists to be the last thing that goes, because you want to make sure that no matter what axis you're going on, you can twist the joint and it doesn't break and doesn't do something funky. So in that case, what we want for our rotation order is going to be Y has to be the first one on there. So it's going to be either YZX or YXZ. And let's just choose YZX. So that now you can bend, you can go to the side, and twisting is always last. Exactly what we want. Cool. The next thing we're going to do is create a curve control for the neck, just like we did for the body there. So create. And again, it's all about consistency here. Since we're using circles for the FK on the back, we might as well use a circle for the FK on the neck as well. So we'll create a circle. And then we can either use that parent command that we were using before, where you do parent add shape NURBS circle shape 1 neck anim, like that, or you can do something even cooler, where you select the NURBS circle, then we're going to select the neck anim control, and then there's a button here on your shelf from the Animator friendly rigging. Click on that, and that basically does that parent command for you. Makes it a little bit quicker to work with. Then we'll just select these CVs and then scale it down to be around the neck, like that. There we go. And then of course we'll just go ahead and delete NURBS circle 1 because we don't need that anymore. And under neck anim, just want to change the name of this to, or the shape, sorry. So display shapes neck anim shape 1. Just all about making sure that stuff is consistent and named correctly. Okay, so we've got the FK control, we've got the IK control here, and the next thing that we want to do is, let's see how that FK control works first. Before we move on, it's a good idea to test it. And as you can see, when we rotate it, if we go into wireframe, the neck control, or the joint, is moving, but the head's not moving. So why isn't the head moving? Well, we never actually told the head to follow the neck. And in fact, we want the head to not just follow the neck. We want the head to be able to follow the neck, or to follow the shoulders, or to follow the body, or to follow all. Remember, we want to be able to move the head in multiple spaces. So to do that, we're going to create various constraints for the head space. So it can follow the translation and or the rotation of the head and the neck and the shoulders, etc. So let's go ahead and create a multiple constraint. So we'll click on our Setup Multi-Constraint UI button here, and we're going to choose the target, which will be the head anim, load that, and the target objects that we're going to be using. Well, we want to, first thing first is we want it to be on the end of the neck. So I'm going to select the neck control and show that in the outliner, and then scroll down and pick neck aim end joint, because that's going to be the end. That's where we want it to sit on the neck. We want it to boink right on the end there. Next thing I'm going to grab is the shoulder anim, because we want to follow that. Then I'm going to choose body, because we want to follow that as well, and then all, so it can follow all. We got these 4 different options. I'll click on the little plus here to add each of them, and the control object is going to be head anim, and the attribute, first we're going to look at the translation, so we'll just call it T space for translate space, and I'm only going to turn on point constraints. So now when I click apply, what it does is it takes the head anim, puts it underneath a group called head anim group, creates a point constraint, and then creates a T-space attribute on head anim with all these 4 options. So right now it's on the neck. So if I grab the neck and I rotate this, you'll see that the head is affected, but the orientation is not. So I can just bend the neck forward and backward and go side to side, and we get some really nice motion on the head. And it stays oriented to itself right now because we're not telling it to do anything specific. We could also change that instead and have it follow shoulder, because right now it's on neck end, but so if I do this, it's going to follow the shoulder, and it's also going to follow the body. But I could tell it, you know what, I want it to follow body instead. So if I take the shoulder and rotate it, the head doesn't move at all. So we can totally lock the head off, which is very nice. But we're going to leave it on neck aim end for now. And then we're going to do the same thing for the orient, and we'll just change this, and we'll call it O space for orient. Or you can call it R space for rotate, whatever you want. But I'll call it O space. Click apply. And so now, when we grab the neck and rotate it, you can see that it follows the rotation of that as well. So you can even go in here and say, you know what? For translation, I want it to follow neck, but for orientation, I want it to follow shoulder. So I can take the neck and use this to bend forward and back and get some really nice kind of interesting head motion. But I still want it to follow everything with the shoulder. like that. So the animator can start offsetting things and really customizing the usage of the head for whatever it is that they want for their scene and make sure that it can basically work the way they want. But the problem is that the names here are really kind of long and confusing. We've got neck, anim, end joint, shoulder, anim, body, anim, all. It'd be a lot easier if these were just named neck, shoulder, body, all, like that, instead of having all the little underscores and stuff like that. So we're going to edit that. We'll right mouse button here, go down to Edit Attributes, and now here we've got our O space, which is the attribute we want to modify. The type O space and the type T space are information for the constraint itself to know what kind it is, if it's translation or orientation. So we don't, but the animator never sees those, so you don't need to worry about them. But we do want to look at the O space and T space. And so here are the enum names. So we're going to just change this to neck, like that. Change that to shoulder, body, and all. And we'll do the same thing on T-space. Shoulder, body, and all. Close that. And now, if we select something else, then go back to the head, you can see it's neck, shoulder, body, all. Neck, shoulder, body, all. Much easier and much faster for the animator to know exactly what it is they're working with. So as for what the defaults are set to, like I said, translate space, I like leaving it on neck. Orient space, either shoulder, body, or all. Just for the sake of craziness, we're going to choose all here. So the orientation will pretty much be independent of whatever the body does, but if the animator takes the all joint and moves it around, it will follow that. Okay? So let's check what our actual animation requirements and make sure that we can do everything we need to. We wanted the head to be able to orbit and rotate and translate and move around, extend, etc. And it looks like that's been solved. We can do all of that. We needed the neck to just sort of follow with what it was doing, which it certainly does. And we needed to come up with a way of doing space switching to move either in shoulder, neck, body, or all space, and we can do that. So it looks like we've solved the motion requirements. Do we have simple controls? Yes, we've got simple controls. It's basically just a joint you grab and or a curve you grab and select and move, and that's correct. Is the animation easily transferable? We have the head set up in a way that's easy to copy the animation. Control should be unique and make immediate sense. Indeed, we do. They should have the correct rotation orders. We checked our rotation orders on the head, and it's the same for the body, so that should be good. The neck control has the correct joint orient and rotation orders as well, so we've done that. Control should be named correctly. Yes, we named our head and neck controls head anim and neck anim, so it's easy to use. Limited key ability. We never attacked the limited key ability option, so let's go take a look at that. So right now, if we look at the head anim, we have scale X and scale Y and scale Z and visibility on there. We don't want to have those. So we'll select them, right mouse button, lock and hide selected. So the head anim only has translate X, rotate X, T, and O space keyable, which is exactly what we want. Let's look at the neck. Boink. Neck has translate, rotate, scale, visibility, all this stuff that we don't need. We only want the rotations. So we'll select those guys, the translations, and we'll select the scales and choose right mouse button, lock and hide selected. Then we'll go to the radius and just hide that one because we don't want to see it. So looking at the outliner, we can tell that it's kind of messy right now. And when we go into our rig presentation part of making sure that the neck and head are working correctly, we're going to end up cleaning this up and trying to make things look a little bit tidier. So since we're looking at it now, we might as well just clean it up a little bit, just to try and make it look a little nicer. So the first thing we want to do is take care of this head anim group, because that's just sitting off here in space. And we're going to take that and we'll parent it underneath anim group with everything else that's in there. Poink, like that. Then let's also take a look at these nodes that we don't want people to be able to grab, like the neck geo, neck IK handle, neck curve, the bases, and the neck distance node right there. So we're going to select each of these, the neck geo, the neck, all these nodes, and we're just going to group those together. Control G. Boink. And then we're going to name them neck group. And we're going to parent those underneath the do not touch group right there, so that we know the animator can't select them and move them. Then we're going to take the head group, which is actually all the geometry. We're going to change the name of this to head geo group. And we'll parent that underneath do not touch as well, because we don't want them to accidentally select that. Excuse me, the next thing we want to do is check the neck curve, because we know that if we, same thing we had with the back here, where if we start moving things around, and we'll end up getting double transformations. If we take all anim and move it, the neck goes crazy. So we want to make sure that that's not going to happen. So we have to find the neck curve, which is underneath neck group, neck curve, and we're going to turn off inherit transformations on that, so it doesn't do that. Boink. Now if we take that, we get a little bit better, but it still kind of goes wonky. And so we want to make sure that that's actually on the neck geo as well. So we're going to take neck group and turn it off on that and see what happens. And now that seems to work pretty well. If we do this, we should be able to grab all anim and move it, and it works just fine. Cool. So we've turned off the inherit transforms to get rid of that problem. And now what we want to do is hide some things that we don't need to see. So for example, we don't need to see the display of the scaling here. So if we find that, we can go under here under neck group and hide neck IK handle, neck curve, neck distance. We'll hide those. We don't need to look at them. We've got these locators here and this top curve bind nodes. We're going to hide that. We'll do the same thing over here. Neck length bot, neck base joint. We don't need to see those. Neck curve bind, hide that. And now we've got our neck control, which works really well. We've got our head, and everything is clean to look at, which is great. But we need to work on our display layers, because right now these guys aren't very interesting. They're just, this one's just the default curve, and this one over here is just basically following the mid animation layer. So we're going to go ahead and add, and we also can select geometry that we don't want to be able to select. So we're going to take the head geo, and we're going to take our neck geo, and we're going to add that to the do not touch layer, add selected objects, so we can't accidentally pick them, which is good. We don't want to be able to do that. And we're going to create a layer for the neck control itself, so we can turn that on and off. We'll call this FK neck layer, and we'll color it yellow, same as all the other mid controls. And we'll take the neck control itself, add that, so the animator can turn that on or off, like so. And then we'll take the head anim, and we'll add that to the mid layer. Add selected objects. There we go. And in fact, you can actually take this neck layer if you want and make it blue, so that it's easier to tell that these are FK controls and the other ones are more translation rotation controls. So that makes it a lot easier to tell what's going on. You can look at that directly and go, nope, we don't want any of our FK controls showing up, so I'll just hide those, and it's all IK. Or we do want to have them, and so the FK is there as well. See? But there's something that we forgot to add that might be really handy, and that is a pivot control for the head. We might want to be able to move the head and actually do things like lean the head, the forehead against a wall or something like that, or anything kind of crazy. Same thing we can do with the body. So we'll simply select the head, and we're going to create a pivot by clicking on the Create Pivot button, like so. And we can now have a pivot for the head. But before we hand this off to an animator, let's just check and make sure that it's doing what it's supposed to. So if we select the pivot and move it, we would expect it to do what it does on the body, which just moves over, say here, and then allows us to rotate the head. But watch what happens if we do. Notice the head is separated. Why are we doing that? And the reason for that is because we have the head geo group, which is this guy, point constrained, or parent constrained, to the location of the pivot for the animation control, and we're moving the pivot by grabbing this locator and moving it around. So that's not going to work. We don't want this to be parent constrained to that, do we? So let's fix that. We'll go to the head geo group over here in our outliner. We're going to basically get rid of this constraint and make a new one. So we'll duplicate the head geo group, delete everything underneath it, just so we have a transform that's exactly the same as the other one. And we'll rename this to head geo const group, so we know it's for the constraint. Delete this original parent constraint, and then we're going to constrain this one, the head geo group, to this new one that we created. So constrain parent, like that. And then we can take the head geo group, or the head geo constraint group, and parent that underneath head anim. So now if we take this guy and we move that and then go and rotate, you can see exactly what happens, and it works just fine. So that solves that problem. Let's go ahead and hide the pivot temporarily since we don't need to see it. And double check our rig relocation program options. Okay, we have limited our control selection. We can only select the things that we want with the animator to select. So when I'm clicking and dragging, I'm just getting animation controls. That's it. I can't accidentally pick anything else. We've set up our display layers, we've made sure only controls can be selected, and we provided the users with the ability to turn on and off the controls easily. We've cleaned the rig, we've removed any unnecessary objects and expressions, we've grouped everything under one node, we made sure that everything is named in a way that made sense, and we provided an interface for the rig if necessary, which we didn't do, but because we don't need one yet. And we should be allowed to move and rotate our rig anywhere and have it still work. Let's just double check that. So we should be able to take all anim, grab it, move it, put it wherever, scale it up, and everything should be working just fine. Grab the head, move it, the neck deforms correctly, etc. Shoulders still work. All of that works just like we expect. Put that back. So indeed, we have followed the rules necessary for the rig relocation program. We've done everything we're supposed to for the rig. So for the head, what did we do? We looked at reference, we determined what was required, we tested a couple of solutions, we analyzed them, we created a clean rig following the guidelines that we specified in our tests, we tested it, and now we have a rig that we can hand off to the animators for the head and for the torso. So the next step is obviously to look at the rest of the body and move on to parts 3 and parts 4 of animator-friendly rigging. Thanks very much. That was part 2 of the DVD series, Animator-Friendly Rigging. Coming up next in part 3, we're going to continue with the biped series, and we'll be talking about arms and hands and dealing with fingers and all sorts of fun stuff like that. So if you have any questions, go to johnandhisdog.com. It's in the documentation. Read the docs, take part in the forums, and good luck. Thanks.